Hello, everyone, and welcome to our WeAreDevelopers DevOps Best Practices Day. And welcome back to everyone who has joined us already in the morning session with the workshop. So now for the afternoon, we have some amazing talks about DevOps. We are starting to talk about decoupling. We will talk about GitOps. We will talk about serverless on the cloud. And we will talk about DevOps at Netflix. So we will have someone from Netflix here who will tell us how Netflix thinks about DevOps and what they do. So with that said, I would also like to say a big thank you to Platform.sh, who are our partner of the day and make this mini conference for you possible. So thank you, Platform.sh. And also for the guys who are interested in JavaScript or learning the latest trends and insights about JavaScript and all of its frameworks and libraries. Please don't forget, we have an upcoming JavaScript Congress coming in November. So actually from November 23rd to 25th. Please check it out and save your spot. As always, stay engaged with us during the upcoming sessions. Use the chat to communicate with each other and also ask your questions to the speakers. There is a little ask button below the chat. Click it and you can submit your questions. And after each session, the speakers will be very happy to answer all of your questions. Also, please treat everyone with respect and be nice to each other. Here is a short video about our code of conduct. Okay, with that said, it's a pleasure to announce our first speaker. He's a DevRel professional at Platform.sh, and he's a true expert when it comes to web engineering. He's a super engaged member of the developer community, hosting and talking at many community events and conferences. And it's a pleasure to welcome Shedrack on stage. Hello, how are you doing?
Hey, Syed. Happy to be here. Hey, everybody. Thanks for joining in. I'm excited to be here.
Perfect. Before we start the session, do you want to give us a short preview of what it is about and what can we learn from you today?
Yeah, sure. So, my talk today is mainly about decoupling, which is like a pattern of a microservices. So in the talk, you would basically understand what decoupling is, progressive decoupling, and lastly, success stories. That's people that have tried, organizations that have tried using decoupling and how it has been so far for them. So it's really going to be an exciting talk, and it's a talk I've been really interested in giving out. So I'm happy that this is the first place that I'm doing it. So let's get it. Yeah,
that sounds good and very interesting. So Shedrack, the stage is yours. Have fun.
Yeah, sure. So let's do this. Hi everybody, my name is Shedrack, and today we are going to be talking about I like to call it a discussion. It's going to be a discussion between myself and myself, basically. So decoupling 101, why decouple, when not to decouple, progressive decoupling, and success stories in decoupling. So we're going to get into this soon. So who am I? Like Said said, my name is Shedrack Akintayo. I'm from Lagos, Nigeria, which is like a country in Western Africa. And I'm a developer relations engineer at Platform.sh. I'm also a technical writer and community builder. I'm very passionate about community building, and I'm really happy to be here once again. So what are we going to be talking about today? We're going to be just running through the following topics. what is decoupling, basics of decoupling, deploying decoupled apps, while decouple, when not to decouple, and progressive decoupling, and lastly but not the least, success stories in decoupling. So let's get started. So before we really get into the talk, we need to understand the basics of decoupling, just so everybody's on the same wavelength. So we need to understand what decoupling is, and I'll just give you a very brief scenarios of what decoupling is. So the basics of decoupling. So if we are talking about decoupling, the best example that would probably want to use is Drupal. So we have Drupal, basically first proper Drupal. We use to manage our content and then customize it with themes and plugins to design our front end. Perfect. Drupal works, monolithic Drupal works. This is just Drupal having a front end of for our application view, then back end, which is usually consisted of PHP and of course Drupal. Then this works. This is perfect. This has no flaw, right? But the user visits our sites. Drupal handles everything for the front end. For Drupal, the user sees the Drupal front end we've made, and the application, and it's basically the same application for everything. This works perfectly. Now, moving on to the topic of the day, which is decoupling. So decoupling basically separates the presentation to of responsibilities to JS application. So it is usually powered by Drupal, accessible Drupal API for content. So in this case now, it is not the same application for everything. It's not Drupal handling the front end. It's not Drupal handling everything. Drupal is really just responsible for providing an API or the back end API that will connect to the front end. So in this case, we can use a front end application of whatever framework. So we could use either it's Gatsby, React, Angular, Vue, whatever you want your front end to be like. You can do that. All you have to do is just consume the Drupal API that you get, and this way we have a decoupled application. So this application, the front end is isolated from the back end. The only way the front end can communicate with the back end is through the Drupal API. So this particular pattern is called the decoupled pattern. It's probably the most popular version of larger microservices decoupled. So that's basically it. And so in this particular case, we will split our application into a backend content management system using Drupal, with a content presentation system on the front end with some JavaScript framework. Like I said, like it could be React, Angular, Gatsby, Vue, whatever really suits your team structure, whatever you have the team power for. Now, so here, if you look at the illustration I have here, I have Gatsby, because it's probably one of the most I'm familiar with. So I have Gatsby there. If you can see the Gatsby logo, and Gatsby, in this case, Gatsby consumes the Drupal API during its build. So whenever we run npm run build and Gatsby is building, it basically consumes the Drupal API and present the content however we specified it on the front end. So this is how the decoupling microservice structure works. Now, the main advantage of this, the main advantage of doing decoupling generally is that we can have dedicated teams on the front end and the back end with fewer responsibilities to be concerned with. So this way we have like a faster flow, a faster workflow. So each team is responsible for their problem. So yeah, I say problem generally because I mean we're all trying to solve problem, whatever microservice architecture we are using. So the front end team is responsible for just the front end, and the back end team is responsible for just the back end. So this way, it's basically a separation of concern, like I said initially. Now, one of the responsibility, one of the importance of this is the fact that this way we can hire from a larger pool of JavaScript developers. So I don't know if you know this, but the JavaScript community is really, really big. A lot of people are actually coming to the JavaScript community, and we have a really, really large pool of developers. So we can easily recruit more people for our team, not just someone that is specifically good at Drupal, which is probably rare. It's not exactly rare, but it's not as much as, like, the JavaScript community. So, and hopefully when it comes to debugging, we can hopefully debug better because the systems are isolated from each other. So when there's a problem on the front end, we can easily solve that problem compared to when it's monolithic, where we have to do a lot of, like, searching through code bases. But when we know when there's a view broken in the front end, we know that, okay, we need to just go to the folder where the React application or the Gatsby application is, and do our debugging there. And if it's something on the back end, we go where we install Drupal, and we can easily go there and search whatever we need to do to solve our problem. So it is some of the, like, importance of decoupling generally. So if you can see the illustration by the right, one of the important thing is the way the team workflow is. With Platform.sh, you can see how people can easily, if you have a decouple app, people can easily, make updates to whatever section of the system. If it's the front end, if it's back end, people can easily do that without actually affecting the main app. This is really, really important to make sure that your app is not, whenever there's a bug, it's not really app is not taken down completely. It's really, really important. Now, how do we deploy, like, decoupled app? Now, I'm going to use an illustration with Platform.sh on how you can easily deploy a decoupled app. So Platform.sh has what we call a multi-app, right? Which is a project, a cluster which contains a cluster of containers communicating over various over a particular internal network. So assume you have a box with two boxes inside that have a, like, let's say they have a single link bridge connecting both of them. So this is how a Platform.sh multi-app container looks like. The first box can be your front end, the second box can be your back end. So, and all of them are in the same box. So this way we can make certain changes within that particular box. So each app resides in its own subdirectory, which is the first box and the second box. I like to use illustrations when I'm, like, giving talk, just so people can be on the same wavelength. So each app resides in its own subdirectory. There's a main directory which contains the main app, and then the subdirectories which contains each of the app, the front end and the back end. Now, they can also communicate over a relationship where Gatsby pulls content from API. So that relationship is where our content is coming from, which is going to be the Drupal API, right? That's the relationship. The relationship between the front end and the back end is the one thing that connects them, which is the Drupal API. The Drupal API serves content to the front end. So after that, we can also build the app and serve or configure environment dependent builds. So we can have start date servers, live previews, etc. Now, for in terms of, like, being a single project, we can also develop alongside each other, teams focused on a single app. So we can make sure that teams are, like, developing alongside each other, and the project is basically growing. So next stop would be how the folder would look like. So of course, we're going to have a .platform, which is where we can do, like, every single configuration we need, the applications, the YML file, the routes, the YML file, the services, the YML, then of course the Drupal and the Gatsby folder, which are the subdirectories that I mentioned. So so in this particular case, we actually have a single repository with a directory for each app, right? We have a single repository. Now, this basically builds a cluster of containers that can be communicated with across each other, like within an internal network. Like I said, the box with the box ideology. Now, so this is exactly, so if I were to deploy let's say a Gatsby front-end app and a Drupal backend, this is exactly what my platform.app.yml file will look, which is the file that's responsible for your application configuration. So we have the name, we have the type, of course, which is Node.js. Then the relationships, like I mentioned, like I said, it communicates over a relationship where Gatsby pulls content from an API. So this is a fully decoupled app. So I have to specify that it's Drupal. I need Drupal to I need Gatsby to access Drupal doing build. I need Drupal to do that and Gatsby to do that. Then after application has deployed, what next should run, which is an npm run build. This is where the consumption of the JavaScript of the Drupal API comes in play. Then, of course, the normal commands to start the web server. So this is basically how I can successfully deploy a decoupled application on Platform.sh without really doing. There's not so much stress that comes with doing this, because the way Platform.sh is built is actually Platform.sh is built in a way that it supports decoupled application. Decoupled applications are first class citizens on Platform.sh. So it's really useful for you when it comes to deploying multi apps or decoupled applications. Now, for example, this is an example of a Drupal, a Gatsby plus Drupal application on Platform.sh. The front end here is handled. The front end here is handled by Drupal, and the is handled by Gatsby, and the back end generally is, of course, Drupal. So if you can see the screenshots here, this is actually a Drupal app, a Gatsby app with the Drupal backend. So Drupal is responsible for generally for content, whatever we see on the front end, while the Gatsby is basically defines how we want the view to look like. We can maybe, okay, this particular way we can say, okay, we need the images to be in the middle of all the text. We need to be in between the text. That's really that at this point, that's really Gatsby problem, not Drupal's work. At the moment, Drupal is just really interested in serving this particular content that we have in our CMS to the front end, which is Gatsby. Now, the next thing we'll talk about is why decoupled, advantages and improvements. Why, like, okay, I've been talking about decoupling, the basics of decoupling, and how we can deploy decoupled apps. But you know, every single thing in software engineering generally is trade-offs, right? We need to know if this is really important for us, right? If we need to know the advantages of making a particular architectural decision, so that we do not acquire technical debt over the years. So we need to be sure if decoupling, when we can decouple, if it works for us. Now, the reasons to decouple your app, the pros, which is of course the good part, is focus. Every team has dedicated responsibility, right? Expert teams with dedicated responsibility, with an abstract enough API, teams can focus on one part rather than the whole site. Not just experts on the front end, WordPress expert on the back end, which is basically a dream team, right? We have every single team is responsible for their part of the system, and this way bugs are faster to catch, right? We have many more people working on the product, and overall the code base looks really understandable. Okay, if I'm a front-end developer, I know exactly where to go to look at the code base, to look for whatever I'm looking for. And if I'm a WordPress expert, I know exactly where to go to in the code base to look for whatever I'm looking for. So it's really important. It provides focus for each particular team. Now, the next thing is hiring experts. So better recruiting around other languages. So far more talented Node.js developers are out there than WordPress and PHP. Like, I wouldn't say far more talent. I really would say that the amount of Node.js developers that are out there is quite more than the WordPress and PHP developers out there. So this way we can recruit enough people on the front end. We can also equally recruit enough people on the back end. So we're not restricted to just one type of developer, WordPress developer. So it as if we're using monolithic Drupal, we need to look for someone that is like really special good at Drupal, just Drupal, which becomes a really big problem when we need to move fast, when we need to hire more hands. But when you decouple your app, your Drupal app, you decide to use, okay, on the front end we have Node.js developers, and on the back end we can have WordPress experts doing their thing. So that way more people can be come on the job. Everything is the job is moving fast. So the next thing is interchangeable front end. You can use the tools best for the job. Gatsby, React are far better and more flexible at solving the front end problem. Don't rely on plugins. I mean, Drupal will provide plugins for you to do necessary things, but when you have the flexibility that Gatsby or React gives you on the front end, you would really see that it's not really advisable to rely on plugins to do certain things, right? Plugins can the creators of plugin can decide to, I don't know, make a mistake or something. So this time you are responsible for every single code that is coming into your code base. That way we can analyze, okay, is this right? Is this process the right way to do? How can we prevent technical debt going forward? How do we make this particular function even faster? We have the responsibility to do that. We have the flexibility to do that when we handle the front end ourselves, right? Next is interchangeable front ends. Again, app requires an abstract API. Of course, there have to be an abstract API that is really available for us to switch out the front end to the newest and best framework we need. So if we need a particular solution and maybe React is not providing that, we can switch to Vue. If something comes up in Vue that is not really good for our product, we can decide to, okay, let's do Angular. But for this to work, there needs to be an abstract API that will enable us switch out to the newest and the best framework that we need. And lastly, many heads, of course, same backend consumed by multiple frontends with different purposes. So we can use multiple frontends to build different things with the same backend. So these are like the pros of decoupling your application. And personally, I think this is just enough to get the job done, right? To make sure that our application is growing. Now, next up is many heads across many things. So not headless, but many headed actually. I don't need my content on just one site, but a lot of sites, right? And for different devices or for slightly different audience, this way I can control my content. I can control the way where my content is being placed, where my content is, and we can also have many teams collaborating at the same time. So headless is a bit of a misnomer. Removing presentation responsibilities from Drupal to one or many sites, one for each device, one for each regional site. We can control this way. We can control what our users are seeing. We can do that. We have the access to do that. We can also keep content in sync across all of them. So this decoupling, decoupled architecture gives us that flexibility. So now that we've talked about the pros of decoupling, what about the cons, right? There are a few trade-offs we need to make whenever we make an architectural decision. So we need to understand the why, the how, and also need to understand the disadvantages, which is the cons of doing certain things. So let's look into that. So reasons you might not want to decouple your apps. I mean, I can sit here and talk about how interesting decoupling is, how it can improve your workflow of your development team, but it would really not be nice of me to not talk about the cons. Like, okay, what are you getting yourself into, right? Reasons why you should not decouple your application. Now, after this, then it's up to the engineering team to decide, okay, what is the lesser evil, right? What are the cons more than the pros? Are the pros more than the cons? Should we make this idea? So should we do this particular type of architecture? Now, the cons. Now, work to get there, double the concerns, rewrite tools, constant vigilance. Of course, I'm going to talk about all of this. So work required to abstract the API. Like I said, in the pros, I was talking about how you can have multiple, we can have multiple switch out the front ends, but we have to make sure that we have an abstract API. So decoupling means removing context or dependence of front end from the back end. Like, so the amount of work that has to go into creating a strong API that can be consumed by anything without any assumption, it's a lot, right? We have to put in that work to do it. So that's one of the cons. You might not want to do it, especially when you don't have time, especially when you need to move fast. So we also have, of course, we have to do 2 times tests. We have more security concerns to worry about because there are 2 apps, there are 2 teams, double the test and security oversight. So we have to worry about 2 things this side. We have to worry about this security on the front end. We also have to worry about security on the back end, which is a lot of work. And we also have to have 2 teams, which is, of course, Of course, a lot of cost, right? Because we are paying two different teams to get work done. So it actually has a cost too, cost effect too. So we write to supported by monolith. So plugin ecosystem establish workflow standards that will need to be written from the ground up to continue supporting this work. So if we need to we need to decouple our application, we would probably want to rewrite certain tools so that it can support our work on the on and that is now that we have decoupled our application. So that's another pain point we need to think about. Now, the next thing is team isolation. So here's a promise: front end and back end teams need not to worry about back end or front end engineering, right? That's the promise the couple applications give us. But the reality is that work is necessary to keep coordination and visibility, especially when hosted in two places. The amount of work that we need to put in to make sure that everybody's on the same page is also something that requires us to think about, right? It's really, really important that every single team is in sync. Everybody is in sync, irrespective of where each of the team structure we fall in, whether you're in the front end or the back end. Everybody has to be in sync. So with time, you would see we begin to ignore certain things, and which is really, really not advisable. But this is how the coupled in architecture would get our team to look like. So we need to like consciously put work towards making sure that everybody's coordinated, visibility is there, and especially when our code is hosted in two places, it's really, really, really difficult to do that. So that's something, another pain point that we need to actually put in focus. So these are the cons, these are the pros. You need, as an engineering team, you need to sit down and figure out, okay, this is what would work for me, this is not what would work for me. Can we take over the lesser evil, which is, okay, I want to decouple. I really don't care about the cons. The cons are not really really something that we can handle. Feel free to decouple. Now, the next thing we would be talking about is progressive decoupling. Now, progressive decoupling is a bit different from full decoupling. That's the one we've been talking about, like full decoupling. So progressive decoupling is kind of not very popular. A lot of people are actually not using the progressive decoupling. The space is really, really not that touched. So here's what I know and what I can tell you about progressive decoupling. So from progressive decoupling, you get all the benefits of decoupling while avoiding some of the downsides. So like I mentioned a bunch of disadvantages that comes with regular decoupling. That's full decoupling, right? In progressive decoupling, a JavaScript framework is layered on top of the pre-existing Drupal front end, right? So we can we basically take our Drupal, that's our Drupal front end, and still put. So we have a Drupal DB, we have a Drupal front end, and still put a JavaScript framework on it, which could be React, Vue, or Angular, or whatever framework that you decide to use. Now, the best way of progressively decoupling a website is to use widgets, because this gives us the flexibility they provide. So with widgets, we can easily install it on our CMS. We can easily do what we need to do because they are standalone applications by nature. So ideally, they adhere to the decoupled principle. Now, also, it appeals to both developers and content editors. So in this particular case, when we basically do full decoupling, we are sort of like ignoring the content editor side of things. That's the site layer. People are interested, that are important, that are responsible for the site layout. So, but with progressive decoupling, it actually appeals both to developers, because developers can leverage whatever JavaScript framework of their choice without having to mess with the content editor or content editor workflow. And the content editors still have their Drupal CMS structure. They can upload whatever they need to upload, and they can make updates to whatever they need to update. So this way, we actually have a balance between our developers and our content editors, because these are people that this is the full team structure responsible for the entire product, the entire site generally. So while we've talked about progressive decoupling, one thing we also need to talk about is of course, the disadvantage. I am very big on talking about the advantage and disadvantage of anything, so that I do not mislead people. It's really, really important to talk about every single thing has a disadvantage, whether we agree to it or not. It actually has a disadvantage. So, what are the drawbacks of progressive decoupling? Progressive decoupling does not leverage server-side rendering via Node.js. So, we need to do a lot of work to get the benefits of server-side rendering that would normally get if that Node.js provides. So we need to do a lot of work into making that happen. Better SEO that comes with server-side rendering and faster page loads. So we need to make sure that we are going to do extra work when it comes to getting the benefits of server-side rendering that Node.js provides, since we're already using a front end that is, of course, Node.js, whether it's React, Vue, or Gatsby. Now, higher costs, of course, we need to spend more time building different front end. We need to spend more time hiring more JavaScript people to come in to work on the front end. So the cost is a bit higher than when we decide to just decouple, not even decouple, and when we decide to use normal full decoupling. Now, lastly, David, I forgot the name of the person that made this code, but David said that JavaScript assertion is not going to stop anytime soon, because JavaScript keeps going up. We keep seeing breakthroughs in JavaScript community. So therefore, the risk of sacrificing some of Drupal's popular capabilities might still seem insignificant compared to the JavaScript advantages at the front end. So people might still decide to use JavaScript always at the front end. So now it's up to us as a team to find exactly what works for us. It's very, very important to know exactly what works for your team, because, like I said, everything in software engineering are basically trade-offs. What works for me cannot work for person B. What works for company A cannot work for company B. So we need to actually really sit down, have a discussion with engineering team, go through the cost and benefit, a pro and benefit analysis of whatever architectural decision we are about to make. Next up this is my favorite part, which is decoupling success stories. People that have actually decoupled stuff and how we really help them. So the first thing is for the first case study is the International Film Festival in Rotterdam, which I think is in Netherlands, and Bost. So Bost is the digital agency. So pre-pandemic, the film festival was running on a single Drupal 7 site, which is great, which works normally. But the challenge is that since everybody was moving to, staying at home, and nobody could attend film festival because of COVID, and they needed to improve site readability and also the festival credibility. They actually needed to make a better site. So what they did was with the decoupling architecture, they delivered 100% on the online festival, which opened up for further microservices enhancement towards a general streaming platform. So this way, they actually made a really, really large improvement to their app. And they also created a flexible virtual platform that sets the stage for new, exciting digital opportunities and experiences for future festivals. So they were able to build a decoupled, a fully decoupled Drupal app that they could give their attendees even a better user experience on the front end without really, really affecting their existing Drupal site. If you need to read the case, I'm going to share my slides after this for everybody. So if you need to read the case study, please do so. It's really, really interesting to look at. The next stop is Open Social, decoupling in progress for a SaaS. So Open Social is basically a fully decoupled SaaS product, right? It's really, really a fully decoupled SaaS product. What they do is they provide a Drupal installation profile that they sell to users so that they can get their own community site. So if you need to get your own community site, Open Social was like really helps people do that. So the reason why their product generally is decoupled is because it allows independent development. Like I said, each team is focused on a particular aspect of the system. Now it also opened us up to more integrations and external channels. So this way they can serve their users better. They can provide better. They can serve their users. They can also provide better infrastructure for their users generally, and also provide more integrations for whatever use case their users may have. So one of the reasons they decided to decouple the application. So also decoupling has provided Open Social a platform that is faster, leaner, more flexible, and easier to continuously update and improve. So that's one of the benefits that decoupling using the decoupled architecture is provides generally, because since the systems are isolated, we have the front end here, we have the back end here. It's really easier to make certain updates and changes. For example, I have a film festival that has different themes per year. Like when I say teams, different teams could be, this year could be maybe sci-fi, next year could be fantasy, the other year could be non-fiction. So I need to be able to design my site in such a way that it matches the theme of that particular year. With the coupled architecture, we can easily make changes to the front end every year without actually with the front end every year without actually affecting the back end that Drupal provides. So if you are making a change, we know that we just need to go to the folder, the subdirectory that contains the React app, and do our changes there without generally affecting the system, the entire system. That way we can easily make faster and updates and improve our sites generally. So that's the benefit of decoupling application. And with that, I've come to the end of my talk today. And yeah, I'm super excited to give this talk. Thank you so much for having me. And if you have any question, I'm here to take your questions. Thank you again.
Hi, Shedrack. Thank you very much for this interesting and brief overview about decoupling. Very interesting. I saw on your last slide your email address, first name dot last name at Platform.sh.
Yeah.
Is it a trick or does it work?
It actually works. So I like to put it so that, I don't get spam emails and, I like to do it that way.
Okay. Good. So let's see. We have some questions. First, someone called H. So just the character H saying, very nice presentation. Thank you. Then Kurt, you mentioned when talking about the pros and the cons, you mentioned like what's the lesser evil, go for the lesser evil. So Kurt is saying lesser evil, that's the story of my dev life. Connie is asking, does it make sense to decouple if you are working only with a small team on a simple project? Seems like more work in total besides all the pros.
Yeah. So this is personally my opinion. If your team is like is a very simple project, I would not advise you to decouple, because at that particular time it's really not needed, right? You need to do a simple project with a small team. Then decoupling is not really the idea. So the idea of decoupling is if you need a large you're trying to manage like a very large project and you need to go for a microservice architecture, that's when you probably want to decouple, right? But if you have a small team, a very simple project that you don't maybe need to just render content on particular front end, you don't need anything special, then just don't. Personally, don't decouple. Somebody might come with a different ideology, but me personally, don't decouple, because you just make life more difficult for yourself and your team. So yeah, that's my idea on decoupling whether on a small team.
Okay, so maybe generally saying if you don't need to scale the team or the product, then maybe it's better to don't do
to just stick with regular monolith Drupal.
Yeah. Okay. Then there was a question which I found very interesting. I mean, you used Drupal as a use case here, but actually you could use any framework or whatever. Kalle was asking the very beginning, what is the advantage or why is someone using Drupal as an API? Because it's a full-sized content management system or framework. I think they call it framework instead of system in that case. But like how? Why do you use this example, or why do people use that?
Yeah, so Drupal is when it comes to decoupling, Drupal has a lot of success stories when it comes to decoupling. A lot of people actually use Drupal for the whole decoupling ideology. I think in the Drupal community, I've seen more use of the Drupal of decoupling, progressive decoupling specifically, in the Drupal community. So it only makes sense to actually use there because these are spaces I can get success stories from. But in the whole concept of decoupling, you can use whatever system architecture you programming language framework that you probably need to. But Drupal is built in such a way that it actually adheres to the principles of decoupling even better. So that's one of the reasons why you'd probably see a lot of examples, mostly on Drupal.
What I learned with Drupal, I was working like for a couple of years in the marketing industry, and what I learned is like that there is really big sites out there, big web applications running on Drupal and becoming bigger and bigger and bigger, and at some point they become really inflexible, and that's maybe also the point when you could think about, okay, let's
Decouple application,
decouple this, yes, and make it from monolith to something different. So maybe that's also the reason. Also goes with the question from Lucas, who is asking, is it advisable to decouple existing applications or better just when you begin a project?
It depends. Most of the time I've seen decouple happen, right? I've seen people decouple existing projects, but that requires a lot of work, right? You need to spend more time, abstracting your code base in a way that you can switch out front ends, you can switch out the front ends without really affecting the entire application. So there's more work's going to that, but it's really doable, right? But just that you need to do more work compared to like starting afresh, building a decoupled application from scratch. It's doable as long as you have the manpower, you have the skill level to do that. It's really doable and it works, right? So it just depends on whether you want to make that cost or you don't want to do that.
Yeah, it's also kind of an investment in the future, right?
Yes, exactly.
Okay, then Lucas again. He's asking, what is your suggestion to avoid unnecessary complexity with too many clusters? It might become messy very fast.
So I do not really understand that question. Like, does he mean that how do we prevent so since the application is decoupled, right? Since the application is decoupled, systems are separated from each other. The backend developers need to worry only about the backend, and the front end developers need to worry about only on the front end. So the ideology behind decoupling is that this way there is really not so much complexity that we cannot handle, right? Because we know that if a view is broken, I know where to go to fix that particular view on the front end side of it. Because I said each app exists in a different subdirectory, so it's not like everything is in the same place. So that way I can go to okay, this is the Gatsby folder, go there, search whatever I need to search and fix the bug. And on the back end too, the promise that decoupling will give us is that whenever there's a backend issue, maybe a particular content is not being served, I know exactly where to go to see to make. I know I have a smaller range of places to debug my application compared to when I use a monolith application where there's no separation of concerns. Everything is just in one place. It gets even more worrisome. So that's the promise. The promise decoupled applications basically bring to you. You can solve bugs faster and you can prevent complexity even better.
Okay, good, Lucas. If that answers the question, then we are happy. But if you are not happy with the answer, then just please clarify your question in the chat again. Then next one, also interesting. So if everything is independent and decoupled, what's the best practice to ensure a proper level of security and maintain it?
Yes, so if you notice, it is a very interesting question. If you notice in the slides, I mentioned something about a con of decoupling is that you have to worry more about security because you're now having two apps, which is the front end and the back end, and you need to ensure much more 2 times the level of tests that you would write when you just have a single monolith application. So I would say to prevent to have security issues, worry about security issues is you need to spend more time. That's one of the disadvantages of decoupling, is that you need to spend more time worrying about security both on the front end and the back end because these are 2 different apps and there are 2 different ways we can approach security in different languages. And so that's a disadvantage on the decoupling end. You just need to spend more time than you'd normally do checking out security issues and maintaining like a very, very good security checklist.
Mm-hmm. Okay, then there is one question from Mr. or Miss Anonymous. It was, maybe it's a question, maybe it's a comment, but maybe you want to say something. So he or she says, decoupled logic, but a monolithic repository.
Sorry?
A decoupled logic, but a monolithic repository.
Decoupled logic, but a monolithic repository. I don't see how that would work. That could work actually. Having a monolithic repository, that's a single repository for both for a decoupled logic.
Would it
There are situations where that would actually work. I just haven't thought about it yet, and most likely you don't have any comment about it because I have not really thought about that particular thing. But it's actually a very interesting suggestion. Actually, it's actually very, very interesting suggestion.
Okay. And then, I mean, today is about DevOps and not about JavaScript, but there is one question that always comes from Han. He or she is asking you for your opinion on React, Vue, Angular, and Gatsby, or like what's kind of your favorite?
Yeah, so I'm going to try my best to not support any because this is a public channel and I don't want to be dragged on Twitter. So I would say, like I always say, just use what works best for you in a different situation. React has its downsides. Gatsby has its downsides. Vue has its downsides. Which just pick the lesser evil. To be honest, that's my mentality towards this framework. Was just pick the lesser evil. What works best for your team? What can solve your immediate problems faster, and just go with it.
Yeah, that's a really good general advice. And don't just do things for the sake of doing things. Don't decouple for the sake of decoupling, or don't use, I don't know, one of these JS frameworks or libraries just for the sake of it. Do it if you really need it and if you can solve something with it, right?
Exactly. That's the idea.
Okay, then, hey, we are perfectly on time, a bit over it, but it's still perfect. Shedrack, is there anything else you want to share with the community, with the audience?
Yeah, I mean, if you've not tried Platform.sh already, go to Platform.sh to check it out and see how well it suits your team needs. And we also have a community channel where you can easily ask questions. And yeah, we're always happy to serve you. And thank you so much, everybody, for doing this. This is actually my first time on the WeAreDevelopers platform, so I'm really, really excited about it. And I've been dreaming about it. So because I watch WeAreDevelopers talks a lot. I watch it on YouTube a lot. Cool. So yeah, cool. So it's an honor for me to be here. So thank you so much, everybody, for listening. Thank you, Said, for being a wonderful host. And yeah, over and out.
Thank you for being a wonderful speaker, and I'm pretty sure that we will meet again in the future and maybe also in person. Fingers crossed, and have a nice day. Greetings to Lagos.
Yeah, bye, everybody.
Bye. Good. So I think this was really interesting and a very cool speaker. I hope to see him in the future again. Yeah, we are going into a very short break, just 12 minutes, and see you each other after this short break with our next session. Stay tuned. Hey, welcome back to our next session, the second session of our afternoon program. So I'm very happy to announce our next speaker. He is a cloud architect at Crayon. He's a Microsoft Azure MVP. He's an open source advocate. And last but not least, he's also a member of the GitOps working group. So I think there is nobody else who can tell us more about GitOps than him. Please welcome Roberth.
Hi, thank you.
Hi, Robert. How are you doing?
I'm doing well. Our entire company went to the north of Norway and have been doing, team building for a week. So I'm a little bit tired, but I'll try to keep up.
Okay. But you already came back, right? So you have also been
Yes.
part of this team building. Okay, because in the first
Yeah.
second I thought they are now doing team building and you are sitting here.
Oh, I can't do team buildings without me, especially in the north, because that's where I'm from. So I need to brief with all my local knowledge.
Okay, Robert, before we start, maybe you want to give us a short preview of, what can we expect from your talk?
Well, I'm going to go a little bit into the term GitOps and, what it is currently and what it's been and, more importantly, what we can do to make it better in the future. So, a little bit about how that actually works and what actual GitOps is and obviously what we're doing with it and all those kind of cool things.
Okay, that sounds super interesting. So, Robert, I would say the stage is yours. Have fun, and we will see each other later again for the Q&A session.
Yeah, cool. Thanks. All right, let me just try to do all the technical things so I can use my pointer. All right, so thank you. So the session is called GitOps, the past, present, and future, and it sounds more complex than what it really is. It's basically just me droning on about GitOps for a little while, but I'm really happy to be here and to talk about this. I think it's an important subject. And really quickly about me, this is the only branded slide, and the only reason for that is because I can't be bothered to keep on creating news, about me slides for every time I do a thing on a conference. So I just copied this one from the Crayon one. But like previously mentioned, my name is Robert. I'm a cloud architect at Crayon, and I'm based out of Norway, but I work with the Crayon group. So that's the entire, every single country. So we are actually stretching from all the way to in America on one side to, on the tip of Asia on the other side. So we kind of span the entire globe by now. Like previously mentioned, I'm a Microsoft MVP and HashiCorp ambassador. I'm really happy to be part of those two award groups, if you want to call it that. And it's really fun to be part of those that community. And just to keep this short, I do cloud stuff. I'm primarily doing Azure, Microsoft Azure as a cloud, but also I do a lot of multi-cloud stuff. And lately I've been doing a lot of Kubernetes and cloud native things. So, that's kind of how I landed in this kind of position. And at the bottom there, you see some social media things. Feel free to, if you have questions later on or want to get in contact, just shout out at me there and I'll try to do my best to answer everything. All right, that's enough promotion. So I call it the past, the present, and the future. So I guess we kind of have to start with the past. So it might not be the past for some of you, but I'm pretty sure this is kind of how you've been doing your work. Well, most of the time, the last couple of years. And what I mean is that usually when you have a server or be it physical or virtual, you log on to that server. Either through CLI or remote desktop, and you do your thing. And obviously, that doesn't work in the long run. If you have 6,000 servers, you can't log in and manually patch everything. So we kind of started developing these tools to make it easier for us to work with servers and the infrastructure that the code that the developers have been making can stay and thrive on. And we are still doing these things. We're not rid of the remote desktop and SSH or enter PS host stuff yet. We still need to do some of these things, but the more containers have come in, where we kind of like purposely build a small little base of and not in the entire operating system just to host this this one particular piece of code, we kind of starting to see that we're kind of stopping. We stopped doing this, right? Obviously, troubleshooting and stuff like that. So it's not completely gone, but it's starting to get there, luckily. And speaking of developers, after a while, they kind of got their started doing this thing called a continuous deployment that someone spoke about once, and we saw that the developers started doing this continuous loop of developing their code, building it, testing it, deploying, and or releasing it, all dependent on the process. And we as infrastructure people and the people that are managing all the or doing the operations, we were kind of like, yeah, that's cool. We want to do that too. So we started doing that, and as soon as infrastructure as code and or configuration as code became a thing, obviously it made it easier to have these like pipeline based operations thing, where we store everything in Git, and if you put something in there that triggers a pipeline, and there's a process that gets spun up, you get a machine from somewhere out there in the cloud, someone else's computer, and you start running these things, and it takes a little bit of time, but it's better than doing everything manually. And when GitOps became a term, people kind of go like, well, we're doing GitOps. We have stuff in Git, and that's how we do our ops. So is that GitOps? That's kind of like the question that I keep on getting. So we've been doing GitOps. I like someone on Twitter said that we've been trying to do GitOps, but we haven't had the proper tools, and we haven't had the proper technology. In my mind, and in a lot of other people's mind, if you have Git and you add automation, that doesn't equal GitOps. GitOps is not just having stuff in Git and then automating it and things like that. GitOps is something completely else. So what is GitOps, you might then ask, because obviously I keep telling you that the thing that you're doing is not GitOps, and GitOps is originally a thing that people have been doing it, but no one kind of like had a word for it up until WeWorks kind of came up with this blog post where they explained on how do they do the operations. And it's a really great blog post, and even though it's from 2017, which is like a million years in IT time, it still holds a lot of the the core values of GitOps, and it's a good starting point if you're not completely aware of what it is. And like I said, they call it operations by pull request, as it says here, and I think that's kind of like the clue here, where the way that you do development these days on code, you have all these continuous integration parts that kind of spin in before you get to the point where someone looks at all the tests and looks at the code and goes like, yeah, this is precisely what we agreed on. So I go like, yes, that's cool. I approve of this. And at that point, you don't really do a lot of testing. Sometimes you promote that to a different environment and do some security tests when it's built and everything like that. But usually you want to do more things. And shift left is the word people keep on saying. So you want to shift everything left, right? Because at the end there, someone was like, this looks cool, this is good, I approve it, and then you're gonna kind of just get it out there, right? There's no lead time there. You just, if it's approved, it goes out. So WeWorks kind of explained this in this blog post, and it's very centric, geared towards how they do things and stuff like that. But this kind of like sparked an interest from people, and at one point they started a working group called the GitOps Working Group, which then led to a project called Open GitOps. And before I go into to some specific about GitOps, I need to actually also explain what is Open GitOps. So Open GitOps, if you go to the website, it's very explicit about what it is. It's a set of open source standards, best practices, and community focused education to help organizations adopt a structured, standardized approach to implementing GitOps. It was really hard for me after 1 week of team building. And so what Open GitOps is aiming to do is to kind of help people understand what is GitOps and how does this how do we implement that way, that operational model. And also we do event stuff. So, at KubeCon, we have GitOpsCon, had the second one now in North America. We had one in Europe, and, Europe is going to come back again. So we're just going to continue doing that. But this isn't a project that is not from one vendor. So even though WeWorks kind of started off this, they're part of the Open GitOps project and the GitOps working group. But Amazon, GitOps, Microsoft, and also Crayon, is part of that, and are kind of shaping the future of what GitOps means. And one of the most important parts, and which kind of helps explain what GitOps actually is the GitOps principles that has been created. So that's kind of been like the main focus area at the start. Hopefully there will be more like standards and more importantly, best practices and blog posts and stuff that help people get started with GitOps. But we can do that until the principles were kind of set, right? Or else we're just fumbling in the dark. So the GitOps principles. So far there are 4. There's a 5th kind of in the wheel, but everything's through a community effort. So we're talking it over, and the GitOps principles were released in version 1.0. So you can see how nerdy we are. Before that, it was very wordy. I had an internal presentation on GitOps principles and kind of went like this. People just got lost in everything. So shorten it down, made it more concise, more precise, more something that you can actually remember. So the principles are as follows. Number 1, we have the principle of declarative, and as it says here, a system managed by GitOps must have its desired state expressed declaratively. If you go into the GitOps repositories and look at these particular principles and stuff like that, it links to certain things like desired state. What do we mean by that, and everything like that. So if you don't really understand what these things means, feel free to go there. But what it just means is, in short terms, is what we actually have in Git is what we want the systems that we are controlling with Git to be. There shouldn't be any room for interpretation. There shouldn't be a pipeline that must be, have certain rights. There mustn't be someone that 6 people that are controlling it and everything like that. We want things to get put into Git, and when it's put into Git, that is what the system is supposed to be. And obviously, when we talk about something expressed declaratively, we're infrastructure as code is declaratively, but that is just on like a resource level. Declaratively, you declared you want a virtual machine. What we mean here is that the entirety of the system needs to be declaratively expressed. Number 2, I can already feel that my the team building exercises have starting to kick in. Versioned and immutable. So the desired state needs to be stored in a way that enforces immutability, versioning, and retains a complete version history. And this is really, really important. And what we mean is that as soon as you update your code base, you are in fact creating a new version of desired state. Why that is important is because if you, for instance, update something and that version then has something changed and probably maybe something underlying wasn't ready, or someone forgot to, I don't know, flush the pipes of something jargon. Maybe it didn't work, right? And at that point, what do? You don't want to start troubleshooting. Worst case scenarios, you need to do that. But what you actually want to do is, have things fail, get your logs in, get your monitoring, look at what's going on. And if it's in production and you kind of need to get it back, you get it, do a git revert. You just take and go back to the version that actually was functioning. And that's what we mean by enforces immutability. We don't want to change the state. We want to have a new version of the state, the entire state. So we can then go back or improve on top of that in a controlled fashion, and then have the entire history. So we need to go back several days. We will have our complete version history and can just go back to that particular commit. Number 3, it needs to be pulled automatically. And this is kind of where it, kind of differs from what people think, and kind of gets a little bit, I would say a little bit fixed. So we don't want something pushing the changes into the state. The state is in Git, and we want software agents, which is a round term for a robot of some sort, to look and see that this declared state in the source has changed, and then pull that into the system so it can get processed. And by software agents, the reason why the wording is a bit around, I'll get back to, but with software agents in, for instance, like Kubernetes scenarios, that actually means operators or the controller pattern application, which looks at a resource in Kubernetes and acts upon that. And the 4th one is continuously reconciled. So after software agents see that the desired state of the source has been updated and pull that in, then other software agents should take that and see if and as it says here, observe if the actual system state and the declared state from the source, if that actually, if there's any change there, and if there isn't a change, it will then attempt to apply the desired state. So what that actually means is, as soon as something comes in and it differs from what's going on, so if someone's done anything, or if anyone's doing anything, because we will have the desired state laying around, right? If someone does anything or manually, or if someone changes the desired state in Git, it will always be applied to the system. Again, something that kind of differs from the normal like pipeline-based deployment scenario, where you have you usually trigger it. You might trigger it through actually putting it together, or you might trigger it manually, or you might have it, go on a loop or something to try to see if anything drifts, or you can set up some fancy systems. Everything like that needs to be in place for it to be GitOps, and that might be hard with pipelines. You can do that. So if your pipeline or your system, checks all these boxes, yeah, you could call it GitOps, maybe. But at the same time, there are certain tools created for this, so it would be easier to use that at that point. All right. Now that we went through the actual principles and kind of explain what GitOps is, so what are the benefits? Well, first of all, deployment speed, which is after a while, people like me who create pipelines still for people to get their stuff out, with Terraform and application delivery things. Deployment speed is pretty fast already, right? But what we want to do with GitOps is kind of more than that. And from a user's perspective, you want to, put your changes and have that go into a pull request scenario. And if that pull request is approved, you want the speed to be more or less instantaneous. As soon as the change, lands at the source of truth, which is Git, we want that to be the actual state of the system. Obviously, these things need to be. You can't just pull all the time. You could do that, but if it takes a minute, I'm pretty sure if you do a change and then go and check the system, it's probably there before you actually, manage to get around to looking it up. So one of the benefits, or main benefits that I see at least, is deployment speed. Another one is that it's easy to secure, and that kind of needs a little bit of explanation. So if you, for instance, use Azure DevOps or GitOps Actions, or any other CI/CD type tool, Jenkins, etc., you would have to give the deployment process the correct rights to get the things out. So if you're deploying an application into a Kubernetes cluster, it needs to be able to access that Kubernetes cluster. If you're doing infrastructure as code and you're having Terraform and doing stuff, you need to give that pipeline the rights to create the resources when it lands and then goes through. And GitOps, with the tools that we have, are usually easier to kind of set that up. So you usually have most of the time something running locally where you need a change, for instance, in the Kubernetes cluster, which means that every security aspect is contained to the platform it lands on. A developer doesn't need to know this. The process what the developer uses doesn't need to know this. And you can also set up, integrations towards certain secret stores and stuff like that. So while doing, your actual workload and stuff like that, everything like that can be already running at the platform. You don't need to have that in the process to, fetch secrets and stuff like that. So it's giving access and stuff like that. You give access to a certain repository, you allow them to put it in, and it's easier to do branch protection than doing access management in most of these systems. Documentation. I usually say that when I started doing infrastructure as code, I kind of went like, yeah, because then you have your stuff documented, right? If you're defining your stuff as code and you can read that, and it's not real code, it's some sort of like high level language that most people can read and understand what that means. If you have that, you kind of have documentation right out of the box. You need to write some documentation, but not every single piece of documentation. And that's true for infrastructure as code, but at the same time, there's always room for the state to drift, or having someone doing something manual and change how everything like that works. If you're doing GitOps for real, as I said, the get source is then the current state of the cluster always, which makes it a whole lot easier to refer to as documentation. It shouldn't be anything different. If something is different, something is wrong, right? You use tool that developers are familiar with, and that's depends on, I guess, I think, because developers get used to a lot of things these days because they kind of have to. But mainly what you need to know, if you, for instance, base of GitHub, for instance, they need to have their account on GitHub and know how to use Git. You could use any type of Git repository, basically, and it still would just be coming down to Git. You need to be able to do Git commits. You need to learn how to do pull requests, and you need to know how to, for instance, revert the history and stuff like that. Just normal Git stuff. If you change or the platform changes, the developer don't need to care about that, because you're putting stuff in Git. That's it. That's all they need to know. Everything else is in the background doing its thing. Right. It's flexible. And by that, I mean that, for instance, if you do, like me, a lot of Terraform, some of these tools don't just support Terraform. Actually, some do. But most of these tools don't just support Terraform straight out of the box. But since they're all based on this operator model, you could then find a Terraform operator, install that into the cluster, and then the delivery mechanism will be the same, and the operator then would kick in and do its thing. But you can then extend the feature set of your flow here by just adding one tool. And this is true for everything. So if you need something, you could probably just write an operator for it, and it doesn't need to be a big thing. It doesn't need to be that advanced, and it doesn't need to take a lot of space. It's just you can just extend it as much as you want. I have a lot of this. It's primarily open source driven. So even like the Open GitOps project is open source driven, and we have meetings, and stuff doesn't get just approved and done without consensus. So at least we try to. And most of the tools that you are using, or the tools that enable GitOps, are open source and very easy to come by and very easy to find. The problem with closed source is that it usually gets driven towards whoever owns the IPO, I guess, or IP. Not IPO, that's something else, the IP. But for instance, for some of these tools, the people that are working together are rivals, but they have the same goal, and that's to enable GitOps. And the way that the tooling that gets created and how it's a really great way to work out in the open, and it just simply seems to be working better in most cases. And speaking of that, there's a great community. If you have issues with any of these tools, they usually have a channel in the Cloud Native Computing Foundation Slack or something else that you can just go in and talk to, and everyone's open to help. Same with the Open GitOps project and the GitOps working group. Just drop in, ask questions, and you'll get answers from everyone from me to people who actually matters. So just to iterate, the GitOps workflow would then be to add or update a declarative manifest storing Git. That's what I call it. A source operator. I'm just doing this in Kubernetes because it makes it a lot easier. So the source operator sees the change and then updates the. I said CRD, but what I actually mean is that the resource that uses a custom resource definition. So that the operator, which you then have installed on your system as well, can see that and then makes it happen if Git differs from the target, and if it does, then we'll update the target to match Git. And there's some steps here, but in all honesty, it's basically just this. So if you're doing GitOps, what you need to do is just update or add configuration. That's the entire process in a nutshell. Obviously, there's some things around it, and people like me kind of have to make it work, but we do, and we do it with these tools. Segue. These are just some tools, all right? Because I started Googling as well, and there's a lot of things that just pops up, and some aren't adopted into have a lot of user base and stuff like that. But there's like a million of these, to be honest. But the two main ones that people usually talk about is Flux CD and Argo CD. And both of they are CNCF projects, which for me is vital when doing these things. The reason for that is because I know that the CNCF has really strict rules of what constitutes a project, because I'm in a project, and we have to deal with all those things. But it has stuff like it needs to be vendor neutral. So even though Flux CD, which is it originally was something else, and then it was something else, and back and forth. But it came from Weaveworks, right? It's Weaveworks, that the people that made the term GitOps that created Flux, and they've been using it. But they donated it in CNCF, and Weaveworks is now just a contributor to that project. Microsoft and Amazon and Google and GitLab, maybe not all of these, and GitHub, maybe not all of these on all projects, but there's a variety of people working on this to make the tools better, and out of interest of making the tool better. Microsoft uses Flux CD, and and Red Hat uses Argo CD, for instance, just top of mind. But they have, and so they want that tool to be good, and that's why I usually go with CNCF projects. out of that reason. I know the quality will be really high. At the same time, there's stuff like Piped I found. It's a pretty new one, relatively new one. Haven't heard a lot about it, but it looks promising. You get Fleet from Rancher, which I like, says that it can do either one cluster or 1 million. So, if you needed to control 1 million clusters, well, good luck. But probably look at Fleet. And then I have Jenkins X, which is out of the Continuous the Delivery Foundation or Deployment, it's the CD Foundation. And even though it's called Jenkins X, it's not really Jenkins. It's just the same but different. It's the same but for GitOps, I guess. Just making sure that the time is there for questions. Speaking of questions, I'm good at segueing today. Common questions: does it have to be Git? I'll try to go a little bit faster because time is running out. No, it doesn't have to be Git. It just needs to, apply to then that's why the wording is very round. It doesn't have to be Git. It just needs to be something that's immutable and versioned. So it can be basically anything. It can even be a S3 or a storage account or somewhere where you can just put code that you can version. Is it only for Kubernetes? No, it's not only for Kubernetes, but it's really it's easier with Kubernetes, to be honest. There's tooling. The people that do tooling for this are kind of Kubernetes people, like myself. And it just makes sense in that. But if you, and that's why the wording is software agents and not operators. If you can create the exact same and within the principles, it doesn't have to be running in Kubernetes. Does GitOps work in all scenarios? Some will say no, some will say yes. I will say maybe, because that's the only right answer of from anything in IT. If you need to have certain processes and kind of control the delivery mechanism and stuff like that, you can do that in GitOps. You don't have to have it to just as soon as it gets to main, it gets out there. Stuff can happen, and you can do separate environments and everything like that. But the way that I see it, GitOps makes it so that it kind of doesn't need that. If you do all your checks up front, it should be okay. And in worst case scenario, it's really easy to go back. So I say you don't need to think about it like that. / yes, this kind of works in all scenarios, but it all depends. It also depends on the people. The future, because I said I had to do this, so I kind of just doing this. What do I see in the future? I see more community efforts into standards. I want to see, maybe something in terms of a certification for a managed service provider. Like, can we say that we use GitOps? We need to go through the checkboxes, and standards in how these toolings can be shaped going forward and stuff like that. Probably be a lot more like that. More technologies will get GitOps enabled. Like I said, it's just adding controllers and operators. Hopefully, we can help. Testing and figuring out and helping people that want to make their thing GitOps enabled. And it usually is just having controllers or operate or software agents. So I hope to see more of that in the future, and most of all, I hope to see an even higher adoption rate. It's actually, to be honest, quite high already. A lot of people are doing this, but I just simply hope that this will kind of be the. I might be biased, but I hope this will be a very a healthy operator model that one can use. I think it's pretty nifty, and I hope more people do it. So, how do you get involved? Even though it says I, but how do you get involved? Well, first of all, everything happens on the CNCF Slack. There's a room there or a channel there called WG GitOps, as in working group GitOps. We don't have one for the project itself because it's the working group that kind of does everything. So kind of stuck with that. But on github.com/open-GitOps, which I hope is not open-GitOps very soon, there's all the documentations. There's a website. If you want to do a blog post, you can do a pull request there. If you're using GitOps, you can add yourself to the member list there. And there's more things coming, and there's a lot of work to be done there. But we are working, and if you want to help with that, then obviously that's really exciting. most of all, spread the love. Tag things on social medias, yell to people that aren't using GitOps. No, that's not love. Just be out there and talk about how cool this way of working is, and that will help immensely. We need advocates, to be honest. We need those people who get into this and actually help us make it move forward. And we have a lot of great people already. More is always better. And the final way that I see how to get involved is, contribute to your favorite open source tool. That's probably the best way, to be honest. If you like Flux, if you like Argo, if you like any of the other ones, those are open source as well. Get in there and fix bugs and help them make the best tool possible. And that will help people understand. It's the tools that make GitOps, to be honest. If the tools get better, then we're all, we will all benefit from it. All right, questions or comments? Let's see if I can get the window up.
Hey, Robert, thank you for such a nice overview. I think the audience has enjoyed it very much. We do have a couple of questions. Some I saw that you have already answered, but still I would maybe just reiterate it again. First of all, Joseph Barak is saying, great overview, thanks. We just started with GitOps using AWS EKS and Argo CD. Do you have any recommendation or preference on using Helm or customers for app definitions?
In the way that I see it, and the way that everything kind of landed for me, I think it kind of depends on what you're doing, to be honest. Customize is really awesome. And if you set up stuff, not manually, but if you kind of do it yourself and trying to control the deployments, that's definitely probably an easier way to go than with Helm. But at the same time, there's a lot of Helm charts. And at some point, you kind of want to do something, and they already created the Helm chart. So I guess it kind of depends. Like I said, that's the favorite. That's the answer to everything in IT. But you can't go wrong with either. I think some people might think that the Helm is kind of harder to do, but customize isn't without complexity. So kind of depends.
Okay, thanks, Joseph. I hope this was helpful. If you have another questions, please feel free to submit it. Then the next question. There is actually two questions that are quite similar. So one is, thanks for the presentation. Do you know any public studies on performance which I could use to present for my team? And also, I think it is a similar topic. Someone was asking, Ilyas was asking, how do you advocate in your team to move to GitOps? Any suggestions in starting with small steps?
Yeah, so to answer the first one, there are some studies that I think WeWorks published. They have some white papers and things like that, and a lot of people have been doing that kind of like research. I think I can't remember one off the top of my head, but I know WeWorks keep on spamming me with those things. I'll tell them to stop it, because I know it's cool. But they have done a lot of these kind of research. They are the GitOps companies, as they say themselves, so they are doing all those kind of things. And when it comes to doing like the internal advocacy, I think at one point I hope that there will be a complete slide deck and resources to do that from in the Open GitOps project, from the GitOps working group. But it depends on who you're talking to. If you're talking to like stakeholders, obviously you kind of need these kind of things that I talked about. But having just a practical demo, because as soon as people are doing technology kind of see how easy it is to use and how like everything just magically works, straight out of the box almost in most cases, they kind of get sold. So do your internal tech lunches, lunch and learn, or whatever people are calling it these days, and I'm sure that will be very beneficial for everyone.
Yeah, always a good suggestions. Just point out the benefits and show them.
Yeah.
Then thank you for the question, Ilias. Then Cyberpaul is a nice nickname. Is asking, can you give some examples of when one could apply GitOps without Kubernetes?
So I've been thinking about that because I mainly work with Kubernetes, or I want to mainly work with Kubernetes. Obviously, servers kind of pop in and out and stuff like that. I think there might be a case for creating something with like some sort of Azure Functions or Lambda to do certain parts of the deal, but at the same time, I think you kind of need to have your application running somewhere. So it might not be in Kubernetes, but maybe one would need to use either like app services or again, AWS and all those clouds are not kind of my fortes. I can't remember in the top of my head, but any place where you can run containers, because these these operators and stuff like that, they are in containers. They might need to be pointed at certain places, and you might need to do some tricks and stuff like that. But you could do it like that, or have your own process which runs on the server. As long as the principle stands, it's the way I see it, it's still GitOps.
Mm-hmm. Okay, thanks for the answer. Raymond is saying thank you for the presentation. Andre is asking about the recordings. Yes, if you jumped in late, no worries. You can watch it on demand later after the event, so no problem at all. And then H, just the character H, is asking, can the agents be self-managed?
It depends on what you mean by that, but usually these agents are self-managed. So just to go quickly into it, it's usually based on the operator model or operator/controller model of software creating applications. So all it does is looking towards a change or an adding of a resource or a change in the resource, and then figures out what it needs to do. At that point, you kind of need to update you need to patch your stuff. So you kind of need to do stuff like that. But itself, it should be totally hands off. That's kind of the point. You just want to add stuff into Git. Something picks that up and does things with it. You don't need to think about it. So it's completely self-managed. Then you need to troubleshoot, of course. But that's always the case.
Okay. Then Josef, who submitted the first question about Helm and Customize, saying thanks for the answer. We're actually rewriting our own monolith app into microservices, and so far we like Customize more. Okay, maybe Josef, would be nice to also elaborate why do you like Customize more, or why you make this decision. Happy to see your comment. Then Part is asking, would Ansible be a common tool for GitOps as well?
Well, Ansible is kind of in between everything in the way that I see it. Ansible is in itself is not really GitOps. But if you had something that could take the playbooks or and somehow manage them in some sort of way in an automatic fashion, and all you did was saying, I want this server based on this, this playbook or runbook. Sure, it could be used for that, but I haven't seen someone doing that, and I think it's it might not be the case where that is actually going to happen. Those kind of things have a tendency of keeping on to the same type of model they already had. But for instance, infrastructure as code in particular, I think GitOps is more suited for those kind of use cases. And now that we have stuff like Crossplane and all those kind of things that are doing the infrastructure part, but inside of Kubernetes or from a Kubernetes system, that just makes it a whole lot easier. But configuration things and Ansible in particular, we kind of glance in between a lot of these things. I haven't seen any cases where it's been used in that way, though.
Okay, thank you. Then next question. Does GitOps make CI, Jenkins, and so on obsolete?
When you're creating applications, you would still need this, right? You would still need to have a build process, and obviously that build process can then get it put into something like a Tecton or something that can then get controlled by GitOps. But you would still need a pipeline to do these building related stuff. It's not obsolete on the other parts as well. There are always a use case. There's always people that don't want to go into this kind of like automatic fashion. They want that good old-fashioned control, or they want to do the same for development as they do for infrastructure. So they kind of want to have pipelines for stuff because that's what their people are know and do. So I don't think it makes it obsolete. I think it, well, again, biased. I think it's better than pipelines, but again, it's a taste. It's and if you like to do it like that, feel free. If you like to do it in pipelines, feel free to do that. We're not here to, shut down pipelines. We're just here to make have this operator model who is a little bit more dynamic and a little bit more easier to control and understand, really.
Okay, thank you. And then last question from Carl. Bit general, but always an important topic. What about security? How to ensure a proper security level?
Yeah. So obviously you don't want to put secrets into Git. That's true forever. You never want to do that. For instance, Flux have integration with the Mozilla SOPs, where you kind of can encrypt your secrets, or you could, reference other things. You could have your set of something against HashiCorp Vault, or something directly tying into, Azure Key Vault or Amazon KMS, AWS KMS, or something like that. But you never want to put secrets into Git. Like I said, this makes it a little bit easier when it comes to access stuff, because usually it is towards a Kubernetes cluster, and so the things that are doing things are already in there, and you can set up that environment to have everything ready, so the developer doesn't need to have that. And it again, just access control and everything like that is much easier, because it's just normal Git repositories that you give access to, and you can set up, code owners and stuff like that. So the process that you would have to make sure that your code that you get in are secured would also be the process of securing your infrastructure in a way. So from a security standpoint, it's easier, I think.
Is there any best practice on how to manage, a large load of secrets?
I think we're still in the trying to find all the best practices. I think that's kind of what cloud native has been in the past couple of years. We're kind of slowly getting to a point where some things are kind of emerging as a certain pattern. I don't like best practices because it's kind of locked in. But if you have a lot of, there's always a certain tool for that. I like HashiCorp Vault, for instance, does a lot of great stuff. And now that the Kubernetes model of developing things are kind of gone from the inbound and outbound type of deployment style, where you can kind of like iterate on certain things faster. I think we're going to get to a point where, as you can see with the CSI, where you have your secrets, you can store that a different place and just reference that. You can use your favorite secrets tool. That's my point. To keep all those secrets. I don't think there's a standard, but we're better off now than we were before, at least.
Okay, Robert, that was the last question of today, and I want to say also in the name of the audience, big thank you, because it was really an interesting overview of all of the GitOps ecosystem. And I would be happy if we can see you in the future again as a speaker. Is there anything else you want to share with the audience before you leave?
No, just get out there and do GitOps, and be advocates. We like it when people brag, not brag, but share the love.
That's cool. That's very cool. So, Robert, I wish you a very nice end of the week. Greetings to Norway. You told me it's snowing today, so maybe you can do something outside as well. And see you soon again. Thanks again.
Thanks. Bye.
Bye, Robert. Bye. Okay, we are going in a very short break again, just 10 minutes, and then we are going into the next session. So stay tuned and yeah, grab a coffee or something to drink, and then see you in a couple of minutes again. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hey, welcome back everyone to our third session of the afternoon track. Very happy to announce our next speaker. He's a senior solutions architect at Alibaba Cloud. He's based in Munich. He has tons of experience in cloud migrations from one cloud to the other and vice versa. and he has been a full stack developer for more than 10 years. So please welcome Zhang on stage.
Yeah, thank you, Sid. Hi, everyone. I'm Cheng.
Hi, Cheng. How are you doing?
I'm good. Really good
How is the weather
today.
in Munich over there?
Yeah, it's good. Sunny day, but a little cold.
That's cool. I mean, we are in Vienna. It's not that sunny, not that far away from Munich, but yeah, so maybe you have more luck today. Cheng, before we start, what will we learn from you today?
Yeah, today I will present some information about serverless and as well our Alibaba solution for serverless.
Okay, perfect. Then anything else you want to share up front with the audience?
If we have time, probably I hope we can do a live demo. Yeah.
Okay, that would be great. So I would say the stage is yours. We'll share your screen and see you later for the Q&A session.
Okay, thank you, Sid. Hi, everyone. I'm Cheng. So today I will present a topic about serverless on cloud, especially on Alibaba Cloud. I'm Cheng, so I work as a senior architect at Alibaba Cloud, and email address. If you have any further question after our presentation, you can contact me with the email address. Before the presentation, I'm gonna to share you two useful information. Actually, current presentation is also part of Alibaba Group Apsara conference. This is a yearly developer conference. And I share the QR code. You can scan directly and go to Apsara Cloud Community Day. You can find more information about Alibaba Cloud and some technology in the cloud computing area. And you can also use the link. I will add the link in the chat, so you can directly use the link. The second thing is Alibaba Education Platform. This is a portal which name is Alibaba Academic. So use the QR code, you can scan, and you can also use the link to our website. And just go to, firstly, to the membership. So once you go to our website, you can get free membership for 1 year to get useful resource about our Alibaba Cloud. And in the community day, you can find more topic related to Alibaba Cloud and as well the cloud computing topic. Yeah, so, okay, back to our presentation. So I'm Cheng. I work in the DACH team on Deutsch-speaking, Germany-speaking area, and as well the Central European. But if you have any question related to Alibaba Cloud, you can also ask me, even though you are not in this area. So today I will introduce the serverless, give you an overview about serverless. After that, I will introduce our Alibaba serverless solution. Depends on different scenario, we provide different solution. And third part is how to integrate with our serverless solution with current DevOps. Finally, if we still have time, we just do a short serverless live demo. Yep. First, just introduce serverless. So before 2013, almost no people discuss the serverless or FAS, function as a service. Since 2015, AWS released the Lambda service. In recent 5 years, serverless become more and more popular, and FAS is more and more used by a lot of customer and in a lot of different areas. Alibaba Cloud released the function compute since 2017. Due to the serverless, the traditional architecture changed. So we named it architecture evolution. Here is the typical example of web server architecture. Previously, we will use a monolith architecture. So you will deploy, for example, as an e-commerce company, you will deploy everything in a single server, all things in the same server, and you will connect to your backend database to persist the data. Nowadays, more and more company find this is not so good, especially for some huge traffic, and due to the location of the server, if customer not in the same area or same country, the latency will increasing. So more company will change the traditional architecture to backend and front-end decoupled and use more CDN solution to facilitate the static content. For the backend, we also do some revolution. So function computing, and from Alibaba, we provide as well the serverless application engine. In this case, to split backend service as well to make it more flexible and scalability. In the previous slide, normally a function compute just treats simple logic, not treat any complex logic. So if we want to do the complex logic, how can we do that? From Alibaba, there's a service which name is Serverless workflow. So for complex business logic, for example, if you see in the chart, the right one, in this case, it's a placeholder logic. So from customer side, they place an order on the platform. So we have to do a lot of things. For example, from the beginning, we have to reserve in the inventory and charge the payment from customer. Definitely, we need to charge the money and send the shipment, and finally confirm everything. So for this complex logic, each component will be a function computing service. So with the workflow, we can define the logic. Actually, this will be a workflow in this serverless workflow. So you will ask why we're using serverless. We can use a monolith server. It can do everything. Why we need that one? So there are a lot of advantage, and you have to consider from different perspective. For example, from operating and management maintenance team. So probably they will consider something about the server. So we don't need physical server. We don't have so many human resource or so many experienced people who can maintenance the server. So we want to use some platform can provide such things. Yeah, you will ask, the virtual machine can do that. Why we use the serverless? It depends on your business logic. If your business is not constant stable, for example, in the daytime, you always have the same traffic from 0 a.m. to the day night. So you don't need to consider the scalability. But if your business is not so stable, for example, there's some peak time, and for example, for e-commerce company on Black Friday, you will have huge traffic. In this case, you have to consider the scalability. Serverless provide more scalability comparing the normal auto scaling. Another thing is optimization. So since serverless, you have to split your business to small pieces. In this case, you will find the bottleneck of your whole system. For the bottleneck, you can use more instance to improve the performance for the bottleneck. For financial part, due to the serverless, you can have more possibility to do the scalability. In this case, you can save a lot of money. Serverless on default support the microservice, and this is a really modern technology where we use more and more. So this will be our answer why you need serverless. If we compare the actual cost for serverless or a normal keep running server, so on the left chart, this is the 1 day traffic coming to our one customer, so you will see the peak time around 1 to 2 p.m. After that or before that, the traffic will go down. So in this case, we don't need to keep the same backend server during the day. So we can use the scalability serverless solution. But what is the threshold? So in the right part, we can see if our workload, actually, if we count the workload duration together, so there's, for this example, the balance point is 8 hours. So if your workload totally together, one day, over 8 hours, yeah, the traditional way, a single ECS will be the best choice comparing the serverless. But if the workload less than 8 hours, you will get benefit. You will save money from the financial term. So next part, I will introduce Alibaba serverless solution and the advantage use Alibaba's serverless solution. Firstly, just do a short introduction of Alibaba due to the number. So for IDC and the Gartner, Alibaba as a public cloud vendor is the top one in Asian market and as well in China market. In the worldwide, Alibaba is the top 3 public cloud vendor. Check the global footprint. Alibaba have more almost 24 global data center across European, North American, and Asian and ocean area. So overall, we have 7.5 availability zone. In one region, we have minimal 2 availability zone. This can definitely guarantee the fault tolerance and high availability in a single region. Totally, we have around more than 22,800 CDN nodes. So this can keep your website or your web service really low latency and good performance. So back to the serverless landscape. Alibaba provides these 4 different kind of serverless solution. It depends on the workload. So the really light workload will be the function compute. So support really fast startup by second level. So you can define some simple logic. Yeah, actually you can define complex logic, but we recommend not define so many logic inside. Just make it simple. You can use workflow to construct the function compute to achieve complex business logic. We also provide SAE, which is serverless application engine. So you can have you can use Spring Cloud to if your system based on Spring Cloud, you can really good use SAE. So SAE on default provide a lot of features which used by Spring Cloud. If you need more infrastructure things, for example, you want to use a Kubernetes feature, you can use ASK. That is a specialized Alibaba Cloud Container Kubernetes service. The last one is ECI. So this is normal elastic container instance. So that's infrastructure for ASK and SAE as well. So this is a basic container service. If you just need the normal container service, you can directly use the ECI. Just give comparison the serverless solution, serverless Kubernetes and the normal ACK. In Alibaba Cloud, we call our Kubernetes service as ACK. So the traditionally ACK, you have to bind some virtual machine or even though some dedicated physical servers. In Alibaba Cloud, we also provide one potential way, which names virtual node. In this version node, this is a kind of version node maintained by Alibaba Cloud Platform. So we will use ECI. So this is an elastic container instance. This instance can treat it as a single server, but we provide unlimited possibility. So you can add really a lot of ECI instance in this version node. So go to the right part. What is ASK? So for ASK, we get rid of the virtual machine or dedicated server. So all things are ECI. So Alibaba Cloud Platform will help you to handle all the container instance. Go to the lightweight solution, which is function compute. In this function compute, we provide more than 10 different kinds of trigger. So this is function compute is totally event-driven design. For example, you can use the OSS trigger, which is an object storage, similar like AWS S3 storage. So once any change to the OSS can trigger a function compute. So you can, for example, if anyone upload image or media, video or any kind of audio. So this kind of event can trigger a function compute. You can define some media transcode or image processing. And also this function compute can also support other kind of trigger, for example, HTTP trigger or Kafka or other things. Our functions compute support almost all different kinds of programming language. For example, Node.js, Python, Java, and other language. You can also define the custom contained runtime. So it means you can do anything you want, any language you want. So, but you have to handle the runtime things. We also provide a lot of developed tools. So you can use the command line tools or the IDE extension. So one important thing is we provide one solution, which is we named reserved instance. For the reserved instance, you can treat it as a traditional server. So this is also possible by using Alibaba Function Compute. But we recommend pay as you go, so you can get more flexibility. So if you need the cloud computing platform, we create the instance. In the function compute, this is a process flow. As a developer, you will design the code. You can choose any kind of language, depends your use case or your scenario. Once you complete the development, you can upload your code to Alibaba Function Compute. By use API or SDK, you can trigger the function compute service on the cloud platform. It depends on your consumption. So for example, if there are really a lot of consumption in the peak time, so you can use the elastic invocation. So on the cloud platform, we generate more instance for your service, but more instance means more payment. So I mentioned the function compute is the basic service. For if you need complex, you can choose the workflow. Here, in this slide, I add two examples. The left one I mentioned previously. So this is an OSS trigger. So if your user uploads one video, so this can trigger some event. In the workflow, you can define the logic. For example, you need do the video review to check whether the video content is okay for everyone. Is there any uncomfortable content? So you should delete it. So you can define the logic. After that, you can do some transcode and other logic. So you can do any kind of logic definition in the workflow. Another case is time-triggered workflow. For example, you have a lot of service on cloud. So you have to, for example, the log service, you need a analysis on the usage, behaviors of your customer. So you can use the time trigger workflow. So for example, you can define at 2 a.m. Start the workflow and retrieve data from different service. And then after you collect all information, you can send this kind of information to big data analysis and generate some bill to your customer. So you can define such workflow by Alibaba Serverless workflow solution. Overall, so serverless on Alibaba Cloud, we provide actually 5 products. This is 4 main usage. From left to right will be function compute, workflow, and SAE, serverless, and ASK. But if you need use some commercial solution, so for example, you want to use Kubernetes or OpenWhiskey or OpenFast by yourself, yeah, you can directly use that in our ACK, our Kubernetes cluster. So next part, we'll introduce, just do a short introduction about serverless DevOps integration. So we use one example. In Alibaba Cloud, we provide a platform, which is RDC. This is a DevOps platform, similar like Azure DevOps. So in the platform, you can define some pipeline. So this the platform name is Cloud Pipeline. You can define the whole DevOps process. In this typical scenario, when developer push the code to SCM report, so we'll trigger some image building process and upload the image to ACR, Alibaba Container Registry. So for example, if you have server in different regions, for example, in this here, one server on EU, European, and another server in China. So you can define the region replication. So in this service, we automatically synchronize your change from one region, one ACR, to another region ACR. So this process, finally, will trigger deployment to Kubernetes cluster in different regions. Yep. So since we still have time, we just do some live demo. So this is some, I record it, so we don't need to do directly. But if need, we can show you something after the live demo. So in the live demo, I will do, there are 4 things, actually 3 things. So show you how do you set up our serverless tools and environment on the server, actually on Alibaba Cloud platform. Second, we will create a simple function compute application. So in this part, I will show you how to do these things locally and do debug locally. And 3, create a simple serverless workflow. So just show you how to do it in our web console or locally. Yep. Before do the environment setting, I just introduce the solution function compute tools. So on the bottom, we have 2 tools, which is Funcraft and FCI. The Funcraft is used to set the development environment, so you can run your code, your function compute locally. FCI is command line tools. You can push your code, or you can pull your code from Alibaba Cloud function compute. In the center, yeah, definitely we support IDE integration, so you can use Visual Studio Code or IntelliJ. With the extension, you don't need to install the Funcraft or FCI. Actually, these things are integrated or set inside of the extensions. But actually, you can also use our online web IDE. So you don't need to install all these things on the bottom. Just use our IDE to edit everything. So, for example, for Mac OS user, you can use the brew command at one repository, and then you can use the brew install the Funcraft, which name fun in brew. So this will take time to install. But after you install the fun, you can use the command to do use the command to initialize your project. So once everything is installed, you can check the version. If not the latest version, you can upgrade it. Once the fun command was installed, Funcraft installed, you can use it to initialize a simple project. So for example, use the initialize command, and you can choose the runtime environment. In this example, we will use Node.js 12, but you can also choose other environment. Once the command executed, the skeleton of your project will created. The next, this is extension tools. So for VS Code, you can choose in the extension market. For the serverless, you can search Aliyun serverless. So, but actually we have other tools as well. For example, you can see here, there's an Alibaba Cloud toolkit that include all Alibaba Cloud tools. So, but if you just need the serverless, you don't need to install that one. Yep, next part, just do more introduction about the function compute life cycle. So you can see on the left chart, if there's a request, you can define the trigger actually. In this example, we use HTTP trigger. So if a request coming to the function compute service, this will trigger a function runtime. So an instance will be allocated to your service to serve the service. So it means unfreeze instance. Once your logic is done, platform will freeze your instance. After that, so and if there's another request coming, so we will unfreeze your instance. On the left picture, you can see the billing plan. So we only charge during the runtime. You can also set the concurrency, so which means one instance not serve only one request, you can serve multiple. So we charge only the runtime. There are two strategies you can define. You can use a freeze mode or stop mode. Freeze mode will keep all runtime inside the instance. We will keep the runtime. But if you use a stop mode, after the instance was released, nothing will be persistent in the instance. Here, this is an example to use Visual Studio Code because command line maybe is not easy to view. Once you install the serverless plugin, you will see one more bar, navigation bar here. You can click it, but at the beginning, you have to set your access key and access secret. I don't show in this in this demo. Once everything's set, you can synchronize your remote resource. So you can see your remote resource in your account. Locally, you can create a lot function compute service. So for example, this is a demo one. Once you create it, you can see the I use the HTTP trigger to trigger the service. And if you switch to the Explorer window, you can see your project in your local directory. So you can check the code and in the Explorer window. And you can also check the Alibaba Cloud resource. So this is a rows format. After that, you can click the debug button. So the server will start locally. So you can test everything locally. Once start, there's a URL we are generated. You can use the link to access the API inside of the function compute. You can also add some breakpoint. So to do the debug, in this part, the loading script, you can see the path of the loading, the script loading. During the runtime, you can see the call stack, and you can add watch parameter here. So you can see what exactly the value is during the runtime. And in this example, so we create web host. Actually, you can treat it as a web host. So in this endpoint, once you access this endpoint, we'll go to the backend. So stop in the breakpoint. So you can check the value, whether it's correct. So this is really convenient for function compute. If you do in the web IDE, maybe you cannot stop here. So this is convenience locally comparing the online. But you have to set up the environment. On the web console solution, you don't need to set such things. Yep. So if you check everything's fine, you can resume the process. Then you can see the result returned to the browser. So this is a local development. Once everything is done, you can use the button here, just publish your function compute to the server. And then everything is done. After you deployment your function compute to the server, you can refresh here and see the new function compute. And in next part, since we don't want to always do everything locally, you can also do our web console. So this is our web portal. Once you have an account, you can log in and go to the function compute service. You can see all service and function inside of this page. You can see what we created already. When you want to modify some configuration, for example, you want to change the memory for the runtime. So for a small one, maybe you just need 512 megabytes. But if you have really complex logic, need to load more things, you can increase the memory size. And you can also define the timeout and other things in the configuration. And if you want to change the code, so you can go to detail overview to the code. So you can see what you define, what you added locally. Once you upload to our cloud function compute service, you can also see that in the web IDE. So you can see all things. You can directly edit in the web IDE, and you can also test in the website. So for example, you can type the method and the path, just click invoke. So then you can test directly in the web IDE. So here you can see the result return from the function compute, and you can also see the server side information. Yeah. Next part, since we create a simple function compute for the complex logic, we can use serverless workflow. This is the web IDE. Actually, this is a web UI tools. So you can see your define here. Actually, this is write by code. So you can see the code. The logic actually is really simple. So you can add serverless or other kind of function compute inside of the code. And you can also do this locally. So as you see, there's a workflow button beneath the function compute. So you can see what you define in the workflow. So you can see all definition inside, and you can check the execution time, the history execution, and the result. In the content, you can see the definition of the workflow, and you can click the execute button. This will trigger execution on Alibaba Cloud, not locally. Yep, so that's all part of the live demo. Thank you. So if you have any question, so maybe you can type in the chat.
Hey, Cheng, thank you very much for the overview. Very nice. I hope you enjoyed it. So let's see what questions do we have in the chat. So we have one comment from Michael. Alibaba joins the cloud. Klaus is saying, interesting to see some Alibaba cloud stuff and not always the usual suspects. Looking forward to seeing the differences. Helen is asking, what kind of NoSQL databases are supported?
Yeah, so from Alibaba Cloud, we provide, so you can use the commercial one. For example, MongoDB is on default support now as non-SQL database. Alibaba ourselves, we have a product which is a table store. You can treat it as an Alibaba provided MongoDB. So logic, we are similarly, we can provide similar API.
Okay, how does it differ to the MongoDB?
From our side, we definitely recommend our solution because this use more on Alibaba infrastructure. So we know everything, the speed and the stable will be better comparing the MongoDB if you use that deploy on our server. But we also provide such service, so you can choose them in the marketplace. Actually, the main feature is almost the same, but our table store provides huge amount of the size. So if you have a lot data, so we recommend to use our table store solution.
Okay, and it's integrated as it's like from your house, so basically,
yeah,
should work better. Okay, understood. Then Logo is asking, are there any extra costs for the freeze mode?
Yeah. The freeze mode, so you can treat we hold the like the laptop, so we hold the process. We will keep all runtime. We keep all things, including something inside of the instance. So next time you don't need to do the initialize phase. This save a lot of time, can make the function compute more faster.
Okay. Good. And Steffi is asking or saying, I'm not familiar with Alibaba Cloud, but what services are offered out of the box?
I'm not sure exactly the question. Out of the box, actually, we provide all service. If you check in our product website, we provide similar service as Azure or AWS. So if anything exists in AWS or Azure, we have such same service as well.
Okay, that is good to know. And then specifically, there is one question about monitoring tools. Would you like to say something about that? Like how is it monitored?
Yeah. So Alibaba, from us, we have one product which is cloud monitoring, cloud monitor. So this is this service on default can be integrated with all cloud service. So you can use that one. We also provide third-party integration, so you can use Datadog or other solution. We provide API as well.
Okay, that's cool. So let me see. There seems to be no more questions. Cheng, is there anything else you would like to share with the audience today?
Probably that's all.
Okay.
Yeah.
But you have also the academy running, maybe again to repeat for the people who came later and joined us later.
Yeah. Okay. Yeah. Thanks, Sid. This is Alibaba Academy. So this is one kind of education website. If you are interested in any kind of Alibaba cloud service or product, you can go to our website, Academy. Today, you can use this link. I can send you our chat. If you use this link, you can get 1 year's free membership. So you can get all course for free. And you can also try to do some basic examination and get the basic level certificate for free. But if you need more high level, you need maybe you need to pay. But for basic, it's free. So you can try and learn our Alibaba product.
Okay, very cool. Then I would say, Cheng, it was a pleasure having you here for the first time, but I hope not the last time, and I hope that we will see each other again in the future, maybe also at an in-person event. So maybe last thing, like what's the best way for people to reach out to you personally if they have some questions?
Yeah, so you can directly contact me by email. Yeah, you can reach me by email and also possible by LinkedIn.
Okay.
So you can search me by LinkedIn, which is Zhang Cheng Home, CC Home. You can also send me by email. So both reach me.
Perfect, cool. Yeah, then as I said, it was a pleasure having you today as a speaker, and hope to see you soon again. Have a nice day in Munich, and yeah, see you next time.
See you, bye.
Bye, thanks. Okay, we are going again into a very short break, and then we are jumping into the last two sessions of today. First, we are going to talk about like how to do better DevOps, and we will also get insights into DevOps at Netflix, which is super interesting, right? So see you soon. See you in 15 minutes, actually.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello, everyone, and welcome back to this session together with Sonal. Hi, Sonal.
Hi, Syed. How are you?
Hi, good. How are you?
I'm good. Thanks for asking.
Perfect. Sonal, you are Principal Program Manager at Microsoft CSE, but in your bio, I also read that you have been working on a computer program that was facilitated in the Nobel Prize-winning discovery of gravitational waves. Tell us more about that.
Oh, wow. So that was a really long time ago when I was a graduate student in the US. I was a student at the University of Southern California, and they have a very large research division of working on grid computing. And this was an orchestration software for grid computing, which actually was used to load these really heavy physics workloads onto the grid. And one of those workloads was the LIGO accelerometer, which was used for detecting gravitational waves. So it's a very small contribution, but I really feel proud about it.
Okay, that's really cool. That's something you can also be proud on. Sonal, maybe just a short preview. What are we going to learn from you today?
Sure. So my talk today is about DevOps and how you understand DevOps and with how understanding DevOps will help you implement it better. Essentially, what I found that when I talk to my teams and we say, you got to do this practices, DevOps practices, automated testing, the uptake might not be that good when compared to when you explain why you need to do something. So why should you do automated testing? Why should you use a sprint board, etc.? So hopefully this talk will kind of turn the conversation in from what you need to do to why you need to do. And hopefully that will help facilitate the audience to implement DevOps in their teams.
Okay, perfect. Then I would say the stage is yours. Have fun and see you later for the Q&A session.
Yeah. So my screen is on. Oh, there you go. Thank you. All right. So good morning, good afternoon, and good evening, everyone. And thank you so much for joining me for this talk. Thank you, WeAreDevelopers, as well, for inviting me to your forum. My name is Sonal Patil. I'm a Principal PM Manager at Microsoft in a group known as Commercial Software Engineering. Today, I'm here to talk about DevOps and how understanding DevOps can help us implement DevOps better. What is DevOps? When I first started my DevOps journey a few years ago, the first question, the most obvious question that came to me was, what is DevOps? I asked some of my colleagues who are fairly new to this, to the DevOps journey as well. And they said it's a list of, it's a list of practices, CI/CD pipelines, automated testing, test-driven development, blue-green deployments, etc. But for me, that was not what the definition of DevOps was. It didn't help me understand what DevOps was. So I decided, let's try on the web. Like I did a web search on DevOps. A lot of results came back, most of them saying Dev was Dev plus Ops. But how does automated testing fit into this Dev plus Ops definition? So I decided to research the origins of DevOps. Where did this name come from? It turns out that it kicked off somewhere in 2007, 2008, where DevOps evolved as the concept of applying the principles of software development to IT infrastructure management. In 2009, there was an O'Reilly conference where the director of engineering, i.e. Dev, and the VP of Ops from Flickr did a talk called 10 plus deploys per day. It's actually quite an entertaining video, and if you find it, you can find it on YouTube. So I would really recommend going there and looking at it. Because they did this kind of a role play, Dev, Ops, and the issues they had at the time and how difficult software development was at that time. But also what is really funny is you start realizing that you have taken for granted all of these principles and practices that were introduced for the first time in that talk. So now I know how it started, but what is it exactly? Is there a definition you can apply to it? And for that, I turned to two books. The first one, The Phoenix Project, defines DevOps as the outcome of applying lean manufacturing principles to the IT value stream to accelerate the flow of work. The things I took away from this definition was lean manufacturing principles and the objective, which is the acceleration of the flow of work. The second book, The DevOps Handbook, tries to show you how to apply this in reality to real software development. And it does that by defining 3 ways to apply DevOps and talks about the principles behind each way. Now, for some, this is probably still too high level. There are probably some developers in the audience thinking, this is so typical of what a program manager would say. So this talk is actually, in this talk, I'm trying to then make these connections between the principles and the practices. And to do that, I've structured this talk so I introduce each way, and then we examine how certain DevOps practices contribute to its principles. So to get us started, the first way, the principle of flow. The first way tells us to establish a value stream that delivers value to the customer. Any work that delivers value to the customer is part of the value stream. Do you write automated tests? Yes. Does it deliver value to the customer? Yes, because they're going to see less failures in production. Then that's part of your value stream. Do you write infrastructure as code? Yes. Does that deliver value to the customer? Yes, it does, because they can easily set up new environments. Then that is part of your value stream. The value stream flows from the left to the right, from dev to ops, or from business requirements to actual customer implementations. Now, keeping that in mind, the first question I would ask is, why do we have a sprint board? Well, the DevOps first way tells us it's to make work visible. Unless work is visible, you cannot establish, neither can you optimize your value stream. This is the most basic starting point of DevOps practice, according to me. If there's one thing you take away from this talk, is to make your work visible. This is especially important for technology work because it's more or less invisible. There is no car produced at the end of an assembly line. There is often friction between engineers and the managers because they tend to think, why is something taking so long? It's just a few lines of code. Or the frustration you feel when you spend 2 or 3 sprints creating a beautiful API, but you have nothing nice to demo. That's because our work is more or less invisible. A sprint board helps us visualize this work to see where the work is flowing well and where it has stalled. And if the work is stalled, it's not delivering value to the customer. So you make it visible, you put it on the sprint board. And remember, work is only considered done when it's in production, delivering value to the customer. Okay, the next question. Why do we work on one task at a time? This is to limit work in progress. Many studies have found that time taken to complete even simple tasks significantly degrade when multitasking. Imagine this scenario, right? You have a project deadline and you've got so many things to do in one sprint. So what do? You start working on all tasks at the same time. You've got 6 tasks open, you switch back and forth between bugs and new functionality. You constantly lose your flow switching back and forth. You started doing this because you wanted to finish stuff faster, but you end up taking up either more time or quality suffers. Hence, always limit your work in progress. So the next question, why do we commit small changes in pull requests? The DevOps first way tells us it's to reduce batch sizes. What that essentially means is to chunk your work in smaller parts and finish that part before beginning another. It reduces the waiting time, allows for faster detection of errors, faster delivery of value, and less rework. Just to illustrate this, I'm going to show you 2 flows. In the first flow, you can see all the changes are committed, tested, and put together, grouped together in a code review. The pull request takes longer as there are many files to review and many more merge conflicts. After the code is reviewed, it's deployed, but the deployment takes longer because there's more configuration, more areas of conflict. There is a very long waiting time before value is delivered to the customer. In the second flow, each change is committed in its own pull request. It is reviewed, tested, and deployed to production. Here, the wait time is shorter and problems are quickly identified and fixed. Hence, commit small changes in pull requests. Next question. Why do we dev, test, and operate our own code? Now, this seems to be a pet peeve in my experience with a lot of engineers. They're like, you mean I have to test my own code? I used to have an entire QA team before. Or why don't we have an operations team? Why do I have to carry a pager? Well, the DevOps way tells us it's to reduce the number of handoffs. Every time work passes from team to team, there's an inordinate amount of communication and context setting that's required. You have specifications, prioritization, scheduling, ticketing systems, project management systems, documentation, meetings, emails, and whatnot. Yet every time a handoff happens, context is lost. Every handoff is a potential queue, and every queue is a potential bottleneck. And when that bottleneck causes the flow of work to stop, it's not going to the customer, which is why we want to reduce the number of handoffs, and we dev test and operate our own code. Next question, why do we have CI/CD pipelines? And the answer to that is to remove the constraints from the flow. To illustrate this, I'll put up the waterfall model on my screen. And if you're my age, you've probably lived that dream, or should I say the nightmare, that was the waterfall model, right? Each step in the waterfall model needs to happen in a specific order, which means each step is a constraint for the next. For example, you cannot do your design and architecture until the requirement specification is done. When you start your DevOps practice, you start by removing constraints. So let's remove the design and architecture constraint by including loosely coupled architecture. The development team now is not constrained by a team of architects. Design stays in the realm of the dev team. Next, we can remove environment creation by writing infrastructure as code. Again, the development team is not constrained by the IT infrastructure team to have infrastructure ready for their development. Now we'll remove the testing and integration and deployment constraints at the bottom, and that is removed by replacing it with CI/CD pipelines. Now, the customer's delivery is not constrained by sign-off by a test team. Neither is it constrained by deployment by infrastructure team. All the work that is done by development flows through CI/CD pipelines automatically. As soon as work is committed, it's tested automatically and deployed to production. Hence, we use CI/CD pipelines to remove that constraint from the system. But what's interesting is if you look at what's left, you've got analysis, requirement specification, and development. All of these are activities done by the DevOps team, by either the product owner or the developer. There aren't any external constraints anymore, and that is a perfect balanced DevOps team because all the work they do has a good flow of value to the customer. Now that we've looked at the first way, the principle of flow, let's now explore the second way, the principle of feedback. We've established the value stream from dev to ops, from left to right. Now we need to make it a safer, more resilient value stream. The way we do that is by fast and constant feedback from the right to the left. Remember, this feedback comes not just from the customer to the business, but from all stages of the value stream. Let's now look at some DevOps practices that will help us with this feedback and how they relate to the principles. So first question, why do we peer review code in pull requests? The answer to that is to push quality closer to the source. Pushing quality closer to the source gives you a quicker, closer feedback loop. It allows you to detect and remediate problems when they're actually cheaper to fix than when they get amplified in production. A stitch in time saves 9, right? Peer reviews makes quality everyone's responsibility instead of it just being the responsibility of a separate quality assurance team. Also, having developers share responsibility for quality not only improves outcomes, but it accelerates learning for the team as well. So the next question, why do we have automated testing? And the answer to that is to see problems as they occur. If we wish to build a safe, resilient system, we have to work to constantly test not just our code, but also our design and operating assumptions. This again provides you with a shorter, quicker feedback loop. If we compare this to manufacturing cars, before the adoption of lean manufacturing principles, there were instances in some factories where there weren't any procedures in place to detect and fix issues. What this resulted in was cars that had to be towed off the assembly line, because cars that wouldn't even start and had to be towed off the assembly line, and they couldn't start because of faulty or misassembled parts. With software development, the end result is not as obvious as a car that cannot start. What typically ends up happening is you release code that has bugs in it, and you know they have bugs in it, but you release them because you have a deadline, and then they get raised as pry-1 issues in production. The team has to put in late nights and long hours to get them fixed just to keep production going. If we no longer want to operate in this scenario, we need to invest in building better automated testing early in the value stream. Okay, so the next question I have here, why do we stop work to fix a failing CI/CD pipeline? I have received a lot of pushback on this from a lot of my engineers. Do you literally mean stop working? The whole team needs to stop working if a build pipeline fails? Well, the second way says yes, and that's so that we can swarm and solve the problem. It's not just sufficient to detect problems, but when the unexpected occurs, we have to mobilize, put our heads together, and get that flow of work going again. A stop build pipeline essentially means there is no flow of work to the customer. A paragon of this is the and-on cord at the Toyota factory, at Toyota. In all Toyota manufacturing plants, at every work center, there is a cord that workers and the managers are trained to pull if anything goes wrong. For example, if a part is missing or faulty or work is taking longer than it should. Once the cord is pulled, the member who pulled it and the manager try to work together to resolve the problem in, say, 60 seconds. But if they can't do that, the entire production line is halted and the entire organization can be mobilized until that problem is fixed or an acceptable countermeasure is found. Instead of trying to work around the problem to fix it later, they swarm to fix it immediately. The same principle can be applied to software development as a virtual and-on cord. If a build or deployment pipeline is broken, then the flow of work to production is essentially stopped and a value stream has stalled. Instead of postponing the resolution of the problem, we need to swarm together to either fix it right away or put a countermeasure in place for as long as it takes to fix it. So now we come to the third way of DevOps, and this is the way of continual learning and experimentation. We've built a value stream. We've made it safer and more resilient. Now we want to make it a better and more improved value stream. And we do that by continual learning and experimentation. You need an organizational culture of experimentation and learning where all of us are empowered to learn from our successes and failures. So I come to my final question of this talk, and I would like to ask, why do we have retrospectives and sprint reviews? And this is for the improvement of daily work. Learning is not about the learning that we do with new technologies or new coding languages. It's also about the improvement of how we do our work as well. There is a well-known saying that in the absence of improvement, processes don't stay the same. They actually degrade due to chaos and entropy. By applying the scientific method to both product development and process improvement, we can learn from our successes and failures, identifying ideas that do not work and reinforcing ones that do. Remember that even more important than daily work is the improvement of daily work. So with that, I would thank you for listening, and I hope that looking at the DevOps practices from the perspective of the principles behind them will help you drive the adoption of these practices even better within your teams. We'd love to hear your views on why you think we should do DevOps and some of your experiences in implementing it. Thank you. Back to you, Seth. I'm just going to look at if you have any comments or questions.
Hello, can you hear me?
Yes, I can hear you.
Okay, sorry, I had some problems with the AirPods. So thank you very much for the presentation. We still have a bit of time for questions, so please submit your questions in the chat. But before we go to the questions, maybe so now from my side, like how did you develop your passion for the whole topic of DevOps and generally in tech and so on? But
Sure.
then
So
specifically also for the topic of DevOps.
absolutely. So my introduction was to DevOps was in my previous company where we were greenfielding a new solution on the cloud. And if you're going to start a cloud development, obviously agile DevOps is the way forward, right? It's as if cloud technology is made for DevOps and DevOps is made for cloud technology. So that seemed to me the best way to implement or create a cloud platform. But instead of just, as I've said in the talk as well, instead of just adopting the practices, I wanted to understand the principles behind it, because that it helps you be flexible as well. So you're not kind of dogmatic about this is the practice and you adopt it. Helps you with the flexibility, and also it helps you kind of communicate that to your team, right? Again, if you're dogmatic and say, hey, you must have unit tests and it must be 90% or 95% code coverage and it must do that, then you'll have a reluctant adopter of DevOps. Instead, if you tell them the kind of principles behind it and why it's important, then you'll have people who are actually bought into that principle.
Mm-hmm. Okay, thanks. Then let me see. Olivier is asking. Okay, interesting question. Like from Funnel RIS, I hope I pronounced it right. When should we avoid DevOps? Is there actually any case where we would say don't do DevOps stuff? I mean, DevOps is like just more on a meta level, but maybe
Sure.
you can say something.
Absolutely. So I would say the principles of DevOps, why you do DevOps, is something I don't see a reason if you're in software development why you should avoid it. What you need to be, and it comes to the question I asked before as well, said, once you understand why you're doing it, there might be certain practices you want to avoid it. And the reason you might be where the overhead of doing that practice is not appropriate for that team. So for example, if you have a team of 3 developers, right, then there might be certain practices that you want to avoid for a very small team. Or if you have, if you're writing a POC or you're making a prototype, then the overhead of doing all of that automation, it is probably not worth that effort you spend on writing a POC that you're going to experiment and throw away. So if you have to evaluate, you evaluate on the overhead and if it's valid for your situation or not.
Mm-hmm. Okay, everyone is saying thank you for this presentation, a different approach or a different way of presenting the DevOps. Thank you. Again, Funnel RYS saying that was an awesome and interesting talk. Then we have one question from SSD21. I'm sure that's not the real name, unless it's maybe the son or daughter of Elon Musk. But let's see. How many teams do you work with actually?
So I can talk a little bit about commercial software engineering, the team I'm in Microsoft. Probably it's a good segue to that. So commercial software engineering is a team of about 800 developers spread globally. We're a small team in Microsoft, and we work with Microsoft's top 500 customers. We sit with them, we write code with them. So in effect, every 3 months, I'm working with a different team because I'm working with the customers team. What's really exciting about that is because we work together as one team, we get to understand their organizational culture as well, whereas we try to also adapt our culture to working with them. Also, we write MVPs, so we don't really write POCs. We're helping our customer on this journey to the cloud. So this whole DevOps practices, agile, what's cloud first development, all of that becomes part of that problem really. But to answer the question, we've got 4 or 5 teams in my sub year, but because we work with customers, it's like a new team and a new project every few months.
Okay, that's quite interesting. So you also basically get a lot of insights into the market and into other companies. What would you say are some common challenges that they all have, and maybe also how do you advocate for the change and also to go with more DevOps processes and advocate for that? Because sometimes maybe you work with a company where you have a team and then they are maybe a bit resistant for change and so on. So
Yeah.
What's your take on that?
So that's a very interesting question. I work in government, and typically not
It's
all
super flexible usually, right?
Exactly. Also in government in general, the whole cloud adoption has kind of started. So it's in its not infancy, but nascency right now, right? Whereas with, say, finance or with retail, it's probably much more mature. So we are at this stage where when we talk to our customers, it is about the technology and it is about how Microsoft cloud technologies can accelerate their solution into the cloud. But it's also about giving those very good cloud first practices. And because we code with, before COVID, we actually went and sat with the customer maybe once a week or in 1 week a month. And we're sitting together and we're using an agile board and we're kind of running the project in those practices. Our hope is to infiltrate almost those practices in the customer by engaging with the developers at the developer level, rather than going top down where the CIO says, hey, you must do DevOps and this is why. Instead of that, work with the developers, get them on board, and then that often gives you a much better adoption of these practices.
Mm-hmm. Yeah, that's what we also see a lot. Like basically, talking to the developers might have more successful, outcomes than talking with the managers, because the developers will anyways advocate them internally in the company organization to, have a shift or change or use a specific tool and so on. Yeah. Good. Then you mentioned COVID actually. And if yes, how did COVID maybe change some DevOps practices?
So I can talk about these specific like agile practices, the sprint ceremonies. Those became really difficult, actually. Difficult until we adapted, I should say. So all of the kind of sprint retros, sprint demos, where we were so used to, with CSE, we run 1 week sprints. We're really very agile sprint team. Mm-hmm. So once a week, we met with the customer, and that was a chance to demonstrate what we've done and get that alignment with the customer, right, with the product owner. And then obviously when we did design sessions as well, it was great to be on a whiteboard and be able to design on a whiteboard. With COVID, almost overnight, we had to move all of that online. And then we had to find practices to make that work online. The good thing is, because it's a large team globally, we shared. Internally, we do a lot of sharing. DevOps third way, right? Principle of continuous learning. We do a lot of sharing internally. So as soon as one team found a great way of doing something, they just shared it across the board. Why don't you do this? So we had some whiteboarding tools, online whiteboarding tools that we used, or the format of the retrospective. Someone came up with an agenda that works for an online format. But we really had to adapt to online operation after COVID. And even for a team like us, which was quite heavily a remote team already, it was still difficult.
Mm-hmm. Okay, there's more interesting questions coming in, so let's tackle that. Erwan is asking, who resists the most, Dev or Ops?
Ooh, nice one.
Maybe it's better to not take sides here.
No, I think the resistance is to change rather than what role it is. So when people see that it's a large change to what they're already doing, that's when the resistance comes in, right? So if you tell a developer that, hey, you need to carry a pager for production issues, that's where the resistance comes in. Or if you test your own code, or if you tell an ops person, you got to learn how to start writing C# or Terraform. If you learn programming, that's when the resistance comes in. But in the end, unless they come together as a team. So the way we did it, and it worked really well, worked fairly well before CSE, was if you have just take those multiple skills in the same team. So your team has to be really left to right. So you have one ops guy, one guy from QA, one guy from two developers, etc. And then because they're working together, eventually those skills kind of even out. What you do is you assign work so that the people are shadowing the developer, or the ops guy is being shadowed by the tester, etc. And the skills level out. But that's one good way of kind of merging that, is have people from different verticals join as one team and help them think and operate as one team.
That's like this T-shape approach, right?
You mean from vertical to one goal? Yeah.
Yeah, exactly. For also there's like in when you hire developers or when you hire teams or so, then you kind of have this T shape. Like people have some
Right.
specific skills where they are better,
Right.
and then you kind of make this complementary working. So that's
Absolutely.
a very interesting approach. Okay, there is also one interesting question: can DevOps principles be applied to all levels, meaning not only to devs and ops?
Not only to sorry, what dev?
Not only to dev and ops, so not only to developers and operations.
So if you probably have heard of DevSecOps, where it's about applying the security principles or the security practices, the principles are the same. The principles, as we've said today, the principles are the same. They come from lean manufacturing principles, right? It's how you apply to software development. Now you can bring in security practices, or you're a security team and it becomes DevSecOps. You bring in machine learning, it becomes MLOps, right? You apply the practices accordingly. Or if you scale it to one level up, you have things like, scrums, and you've got safe, scaled agile. So those are the practices. But for me, that's a distinction I make between DevOps and the practices. It is the principles, and all the practices kind of nest under them. Agile will nest under them, Scrum, safe, all of them nest under that.
Okay, that's cool, but they share something in common, right? Like the lean principles. I remember at our last virtual World Congress this June, we had MLOps as one track, and it was super interesting. And I think there will be even more. Like DevSecOps is also a very hot topic currently, and I'm eager to see what comes next. Then let's see, Jessica has a question. You mentioned that understanding improved implementation, which makes sense, but is there any stories or examples, insights into how this has improved workflow?
Okay. All right. So understanding DevOps improves implementation. I've got a very real life example from myself. Again, this was before I joined Microsoft, but because we were greenfielding from an on-prem, essentially a disk-based software, to the cloud, we had to take a lot of the existing talent in our company and move from on-prem development to cloud development. And as I said, if you just tell people that, which was the case, we started off with, okay, now we're going to do Agile, we're going to do DevOps. These are all the practices. Make sure you have pipeline set up, use Visual, Team Foundation Server as it was at that time, and do all of these things. The uptake is hesitant. People are hesitant to pick up that kind of, because the boss is telling you do it, but it's not coming from within. They're not really look forward to kind of doing those practices. And I was given charge of one such team. And then I had to go in there and help them understand, why is it you need to do all of these things? Why does the team have to wait till 8, 9 o'clock every night because you have prior one bugs in production? Do you really enjoy doing it? You don't. What is it we can do to make that go away? And how is it we go ahead and do that? So definitely that this talk actually comes from my own experience of how then explaining the theory behind it got people on board, and then they adapted. They went back. They adapted to the DevOps practices as well.
Okay, thanks. Then let's see, what else do we have here? Just a second to scroll through. Piotr from MTU Aero Engines Poland is asking, is DevOps better for software houses or for companies with their own products? Maybe also to add something to this question, because I think the answer is always kind of it depends. But maybe you could also point out maybe some differences in DevOps for different types of organizations.
Okay, so I think for your DevOps practice to be successful, you need to identify a customer, right? So if you're building your own product, maybe that customer is, maybe you have a set of customers that you can get feedback on, or you could have a product owner or a product manager that is your customer. So the main thing for DevOps is first is to identify the customer, because only then you can identify the value flowing to the customer. It could be that you are building a MVP. wherein you don't really have a customer. And if that happens, sometimes the teams have a tendency to say, hey, there's no customer, there's no production, why do we need to kind of do all of this automated testing, etc. You cannot then sell the DevOps practices. So you have to establish a customer first. So if you have an independent software vendor, then maybe you have a customer. You have a real customer that is, there, who's paying the bills, essentially. But if you're a product team, then you identify some, maybe a business stakeholder, a more senior enough business stakeholder as your customer. But I think that's the first most important thing, is to identify the customer. In terms of the practices, I think as long as you're building software, most of the practices should remain the same, right? It's just about, finding the right stakeholders for it.
Also, a bit related to that, very interesting question from Helen, who is asking, do you see different approaches to DevOps in different geo, I assume, locations or cultures?
Yes, definitely. So this is very interesting. And of course, people have probably already heard of the book, The Culture Map, but, there's also the website, and you can go and map those different cultures there. But the adoption can be so different culturally. The team I was talking about was based in Eastern Europe, and I was based in London, and I was kind of managing them remotely. And when I went and visited them for the first time, I could see that translation, it's almost like some things are lost in translation, and not literally language translation, but cultural translation. So I think you have to be really aware and sympathetic of the culture of the team that you're working with. If it's a multicultural team, or it's based in different geographies as well, you have to be really aware of that as well. And in that instance, I think the most important thing is over communication. Make sure you're over communicating. And also the first thing I put on the board, like in the talk, make sure you have a sprint board, make sure it's documented. Everything that is being done is well captured and well documented, because then there is a less risk of a misunderstanding that happens. But just be culturally aware of the team.
I mean, that's also an interesting point, because software development is not only about coding and not only about shipping, but it's also a lot about communication, especially as if you work with distributed teams, with different cultures all over the world, there can be so much miscommunication. So thanks for these answers. I think this was already the last question. There's still one, like from Erwan. He is asking, is DevOps realistic for big companies with lots of silos?
Yes, I would say, Evan, it is realistic. You just have to know how to scale it. So even if it's a big company, you ideally have been able to achieve separation of concerns in a way that it can be run, but you have those individual teams within the companies. And then what you need to do, and if you're talking about implementing DevOps, across those companies, identify some leaders and have a community of practice for DevOps, which is what we did, right? So have this COP there that shares their DevOps practices, their pain points, identifies data points across the company, has boards, has metrics to share, and it definitely can be implemented for large companies as well.
Okay, perfect. Yeah, as I mentioned, this was our last question. It was super interesting. Sonal, thank you so much for joining us. You're joining us from the UK, right?
Yes, that's it. Yeah.
So we already said it's not too much British weather there. Just
not,
a bit windy, right?
Not really. It's warm actually today. 19 degrees. Not complaining.
That's cool. That's cool. Yeah, I would be very happy if you join us again in the future at one of our next events, and maybe also in person. So that would be very cool. I've learned a lot from your presentation myself, and also thanks for answering the questions. It was very nice to have you.
Thanks. I had posted a link to my LinkedIn. So if anyone's interested, please give me a ping and contact me there. And there was a link to CSE jobs as well. So it's aka.ms/CSE jobs. We've got some really interesting TPM and software engineering jobs in the region. So yeah, reach out to us.
Okay, very cool. So if you want to work together, if Sonal on interesting projects, just reach out to her. And yeah, let's see what happens. Thanks again. And see you soon again, Sonal. Thank you very much.
Thank you. Thanks, Ed. Bye-bye.
Bye. Okay, let me see. Unfortunately, I just got the what? Okay, he's still joining. Okay, everything is okay. I thought that our last session is not going to work out today, but it will work out today. So one talk that I was also personally very much looking into is our last session of today, because we will get some insights of how DevOps works at Netflix. So stay tuned and join us in 20 minutes again for the last session of today. So don't miss out on that, and see you in a couple of minutes.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello, everyone, and welcome back to the last session of today. Last but not least, I would like to say, because we have a very interesting guest. Tejas is here with us. He is working at Netflix as a senior software engineer. Hi, Tejas. How are you doing?
I am doing great. Hi, Sean. How are you?
Good, good. You work at Netflix. What can you tell us? Like, how does your day-to-day work look like, and what are you responsible for?
Sure. So I work with infrastructure at Netflix. So what I do is I write storage and infrastructure code that is used by Netflix studios. So Netflix studios produce movies all year, and they need in a distributed world where we have pandemic right now, artists work from different parts of the world. So they need a way to work on shared assets, shared images, shared audio files. I build solutions to enable that. So in some ways, I am responsible for the content creation piece of the pie and not the content distribution piece of the pie. So yeah, I've been at Netflix for a year and 5 months now, and it has been a very enriching experience for me. And I hope to share some of my learnings today with the audience as to how Netflix looks at DevOps.
Yeah, thank you. And also thanks for joining us, because it's, I think, just right in the morning. You're joining us from California. We're here producing and streaming from Vienna. So thanks also for getting up early for us.
Of course, it's fine. I really am excited to be here. And thank you so much for inviting me to be a part of this.
Perfect. So Tejas, the stage is yours. Have fun.
Thank you. Thank you so much. Hi, everyone. Today we'll talk about how Netflix looks at DevOps. And this presentation is a more of a thought that Netflix has towards and the approach to DevOps, really. So the agenda for the talk is I'll just briefly talk about myself. We'll talk about Netflix and how Netflix works. Then we'll get into some of the pieces of DevOps and culture that enable that. Like I said, I am a senior software engineer at Netflix. I work on distributed data infrastructure to support Netflix studios to produce movies and share assets. Before Netflix, I was at Box, where I was working on architecting infrastructure solutions for petabytes of data and millions of customers. I have worked in companies such as Datrium, Tensilica, Samsung, and Apple. And I'm also a keynote speaker. I talk on DevOps, microservices, blockchain, and cloud computing in general. So when you think about Netflix, right, the first thought that comes to your mind is Netflix is this streaming provider that you watch movies that are created by Netflix. So our goal at Netflix is to win moments of truth. And this is how our architecture stands today. By winning moments of truth, I mean that at every point in time, people that view Netflix have a choice that whether they want to continue watching a show or they want to switch to the TV, linear TV, or another provider. So at every moment, we have to win our customer and provide the best entertainment possible. In order to do that, we need architecture and infrastructure that can provide a seamless experience so that when you switch from your television to your mobile app of Netflix or back, you need to continue from where you left. So we invest a lot of effort in designing our infrastructure in appropriate ways. We have compute and storage today running almost out of Amazon. So we use AWS as our cloud provider. We started using, when we started Netflix, we were having our content distribution network, the CDN, which caches the content that is distributed to our users using Akamai. Akamai is a third-party solution. And we started using that CDN, but we soon realized that we would actually be served best if we start owning our own CDNs. So Netflix invested a lot of money and effort in building Netflix Open Compute. And Netflix Open Compute is an open source software that you can actually view it at opensource.netflix.com, and you will be able to see how we've built that as a generic content distribution network. Today, we still use Akamai for UI and small assets, but this is a great example of how Netflix, when it realizes that there is a need to win our customers in a better manner and win moments of truth, we go ahead and we implement the technology that we envision. When we think about the scale of Netflix, right? What are we talking about? Like, is it just the members, or is it also how much data we stream. So Netflix today supports 200 million plus members. We are present in 190 plus countries. We have thousands of microservices that run. We have thousands of daily production changes that happen on these microservices. Tens of thousands of virtual machine instances run in Netflix. Hundreds of thousands of customer interactions per second happen on our app. And we have billions of time series metrics. These are metrics that we capture, which inform us what the user is watching and can help train our machine learning algorithms to provide appropriate recommendations, not just based on what you're watching, but what people other than you are watching and how it can actually influence your decisions as well. We also have tens of billions of hours streamed every quarter. We do all of this with tens of operations engineers, and we do not have a network operations center. So that is how we look at DevOps. Like, we don't have a separate team of DevOps, really. We have no NOC, which is in traditional companies, that is a norm to have a network operations center. And you will see that they will have big screens that look at all the data points, and then they will say that a microservice is running or not running. But if you're capturing billions of time series metrics, then it will be very difficult to look at all the screens and make judgments based on whether a service is up or not. So we try to build it into our culture and into our, like, in general, the way we write software. This is a diagram that shows how different microservices interact with each other. As you can see, there is no way to tell which microservice is talking to which other microservices. This is how explosive the number of microservices are within Netflix. So how do we do DevOps? We really don't do DevOps. And I'm a part of a conference here, which we are talking about DevOps. And I'm outrightly saying that we don't do DevOps. So we don't do DevOps in the traditional sense of how DevOps is looked at. And I'll get into how we view DevOps and how it is different in Netflix. So we don't have systems that say no to our engineers and developers. There are no push windows. There are no guardrails that you can only push within like a particular slot of time. You can only push your change around that, because we believe that our engineers will work from different parts of the world at different hours, and we want to give them the freedom to push their code changes at any point in time and the responsibility that comes associated with the freedom. One thing to note is that everyone in Netflix has full access to production environment. We don't take time to build systems or have procedures or policies that prevent people from pushing their code. What we do at Netflix is to hire smart people and get out of their way. If I hire someone who is good at what they do and is intelligent, then they need to have the freedom to solve the problems that they see best. We also look for people that look to take responsibility that is associated with the freedom and do not wait to be given to them. There are times that some companies and organizations focus a lot on the uptime. And that is very important for companies such as for those that are in healthcare and in finance. And there the repercussions of downtime are very different. In Netflix, we do not focus on having uptime at all costs. And that may come as a surprise. For us, what matters is that we value the price and the velocity of innovation. I want the smart engineers that we hire to find new ways of delighting our customers. Netflix, as an organization, knows that in order to bring out the creative best of the people, we will have to trade some of the uptime for this. It's not that uptime is not important. It is not our first priority. Our first priority is keeping our engineers do fun and interesting and exciting things for our millions of customers. We are at a very core a creative company. We value creativity. And for that, we need people to bring their creative selves to work. And that may mean trading some of the uptime off. So we don't focus a lot on processes and procedures. It is difficult to have a fast-moving organization filled with people solving interesting problems to have someone build guardrails that are appropriate. That is a bureaucratic way of thinking about it. One of the functions of bureaucracies is to take that bureaucratic machine and plug it virtually in any cog and get the output that the bureaucracy desires or wants. There are organizations in the world and without naming names, they focus on the same approach in different parts of the organization because that works for them. There are organizations that hire thousands or tens of thousands of engineers. At Netflix, we have 10,000 employees and we have 2,000 to 3,000 engineers that are serving 200 million people. So we try to remove processes and procedures from their pathway, and we try to be different in that sense. What we do is instead, we try to work hard and find people that are not from the bureaucratic machine mold. We want them to question how we do things. We want them to challenge us and suggest newer ways of doing things. So we trust the people that we hire. That's why we don't have issues giving anyone or everyone access to production. Someone may say that, what if someone can just shut the production down? That is true, but it has never happened. So we continue to have that trust built in, and we don't try to lock our doors. We try to keep the doors open for anyone to access any form of information at Netflix. We don't force people to use a language or a framework or an IDE. We have a lot of JVM languages that we write our code in. Our microservices are written using Spring Boot, Kotlin, Python. I work on a file system that is written in C++ and some amount of Go. There's lots of Rust and Scala and Node.js as well. So we do not adhere to just one principle. It is true that what we do converge on is having a paved path, which means that if many people feel that Spring Boot is the way we need to build microservices, we will have a team that will probably build tools that will make using Spring Boot easier. And we open source those as well. So, but for example, if I'm using C++ in my file system, I'm building the tools that are generic in nature that can be used by anyone that wants to use C++. So that is how Netflix views engineers and standardization. So we do not enforce standardization on people. What we do focus on is enablement. Some years ago, a team that worked on the UI wrote a backend in Java and front end in JavaScript. And then they realized as a team that that was probably what worked for them. But as more traffic started coming in, they realized that Node.js would serve their needs better. So they switched from Java backend to Node.js. And they did not need any approvals to do that. In my team, I use C++, but I analyzed the performance of C++ and Java for a file system in user space and realized that even though Java was being used by many Netflix services and we probably had tools to support that, C++ gave me a better performance for my file system. So we took a conscious decision of sticking with C++. And now we actually are writing tools that can enable, like I said, other software engineers to start using C++ in their code if they need it. We have a team in general in Netflix that will write tools to enable other software engineers to spend time on things that we have hired them to do. We don't have traditional operational fences where the operational engineering group sits behind a fence over which the code is thrown in hopes that it will show up in production. So we do not have silos or walls or fences of any form. What we do have is the ability to make ownership easy, which means you write the code for a software, you build it, you run it. You're responsible for deploying it. If I write code, it is my responsibility to figure out a way to deploy it to production, manage the cluster groups, the ASGs, select the right machine on which the code is run. Spinnaker is a tool that has been open sourced by Netflix, and it's one of the tools that we makes it easy for developers to put their services on cloud. And that is the essence of how we try to make ownership easy for the developers. We don't rely on guesses, gut instinct, or tradition. So we make informed choices based on data. We collect data at every point in the step. When I had to make a decision between C++ and Java, I had to actually run experiments to collect data and confirm that my hypothesis is correct. And as we collect data, we realize that sometimes we have to go back and change our assumptions. And that is the entire process of, not trying to stick to a tradition or not working on guesses. We take informed decisions and informed choices at Netflix. What we do, like I said, it's an enormous data company. We really have 2.5 billion time series metrics. that are collected every quarter. And this is just the operational data. Most of our decisions, actually vast majority of our decisions, are based on data. So Netflix began streaming in 2007, and we were streaming in, it began streaming much earlier, but up until 2007, we were streaming from our data centers. In 2008, there was a fire in a data center. So we actually were down for some period of time. We made a decision to move from the data center to the cloud. And we could have done data centers and we could have found people to do it. But as a business, our goal was to win moments of truth. And being great at running data centers will not help us get there. So what we did was we tried to focus on what we are good at, which is trying to win moments of truth, and focus all our energies on the business problem at hand. And we tried to then find our partners that can help us by running data centers. So we worked with partners to do undifferentiated heavy lifting. We would rather have them do it and build it. So we moved to cloud, and by the year 2015, we finished our transition to cloud completely. Then in the last few years, we've had situations where the cloud providers went down and Netflix went down because of that. So we tried to look at our deployments, how we write services for the cloud, and do we have proper fail-safe and fail-back mechanisms. So that is how, at every point in time, we adapt using data, and that informs our decisions. Today, we look at people, what people watch and enjoy, and we are able to produce the kind of stories that people like. We don't have televisions with graphs that show us what is happening. We are a data-driven and a decision-driven company. So we invest in algorithms that can infer decisions from the data that we've collected and inform us of the next step in our journey. So this is how what Netflix does is we don't do DevOps in the traditional sense. What we do is first thing we go, and when we interview someone, the first thing that we focus on is culture. We ask people to go over our culture deck. We want to know that how we think about things is the same as how you think about things. We value our culture very highly. The result of the Netflix culture looks a lot like DevOps. DevOps is a result of a healthy culture and a healthy thinking. It is not just a set of practices. And if you think that the things that I've talked about do not work where you're working, then you generally, most of the things should be applicable to any industry. And if it is not, then you do not really have a DevOps problem. You at that point have a culture problem. So I think that in some sense, our DevOps strategy is reflected very well in our culture. We believe in freedom and responsibility. Just to reiterate, we believe in context, but not control. We believe in making informed decisions based on data. And we believe in also having informed captains where people can lead the project or program. And that does not have to necessarily be the same person. So with every program and project, there's a separate informed captain who can rise to the occasion and lead that. So that's how we think of DevOps, and that is how we think of our culture. And that's my time. Thank you so much for joining me today. If you think that you align with this thinking and you feel like you would like to explore opportunities at Netflix, please feel free to reach out to me on LinkedIn, Twitter, or my email address. And with that, I am happy to take any questions at this point.
So thank you, Tejas, for the presentation. Super interesting, really super interesting also for myself. Also a very nice way how you presented it. So thank you so much.
Thank you.
We do have some comments and questions. I would say we
Yes.
just jump right into that.
Sure.
So let's see. What a culture is one comment. Sounds like you have a lot of fun at Netflix. DevOps the Netflix way, quite interesting. Then let's see the first question here. Did Netflix have this approach from the very beginning? And also, is it possible to change to your approach from an existing big corporate with old culture? Do you have any tips?
Yes. So Netflix was not always like this. Reed Hastings, our CEO, co-CEO now, realized initially when Netflix was streaming, they were shipping DVDs, and then we started streaming. At some point in time, Reed realized that he actually took these principles from his personal life and then he applied it to Netflix. And he has a book called No Rules Rules. That is the name of the book. And so the culture is reflected in a way that if you hire A people, they will hire A people. But if you hire B people, they will hire C people. So in some ways, hiring the right kind of people that fit your mold of thinking will attract talent and will also mean that they will build on the culture. So it's adapted over a period of time and adapted over the course of time. But most of it is still true to date. So from the 90s when Netflix started, we modified it multiple times, and now we've converged on these are our practices and our principles. We do have, like, for example, one thing that Netflix does focus a lot on, and I have seen in my life, in my time here at Netflix, is freedom and responsibility. Because I have the freedom to choose. I have the freedom to choose any language, any framework. I have the freedom to visit any conference and travel to any part of the world, and Netflix will take care of it. They will pay for it, they will promote it, and they will want me to do and bring my best self. Today, I can choose any software to run on my Mac. I don't have to like get a purchase order or anything. I can just buy it and expense it out, and no one will ask me, because the way we look at money or the way we look at how people spend money is that it is your own company. It's as if you would spend your own money. So that's a very good example that I realized when I joined Netflix, that this is different from where I worked in the past. So I think definitely you have to adapt with time, and Netflix has done that over the course of time.
That's super interesting. So have you already ordered the new MacBook Pro?
I don't feel a need to order the MacBook Pro because that's the exact thing. Like with freedom, it also has responsibility.
Yeah,
Yes.
exactly. Yeah,
Yes.
no, I needed to see this. It was like so fitting into this. No.
Yes. Yes.
So I also didn't order it, and I don't need it. Happy with the current one. Joseph is asking, thanks Joseph for the question. Does Kubernetes play a role in Netflix DevOps?
So we actually have our own, before Kubernetes came, we have our own like container orchestration, and we call it Titus, Titus. I think it is open sourced, but it is like Kubernetes, but it is developed internally within Netflix. So I would say that we don't use Kubernetes at this point. We just used our version of container orchestration.
And that's super interesting. Like, we have a lot of DevOps topics, not only today at this mini conference, but at many events that we are running currently, and also the World Congress. And this approach is really interesting, especially like from Netflix, because it's not a small thing. Leonidas is asking, are you multi-cloud?
We are not multi-cloud at this point in time. We are definitely hybrid in some ways. And the reason is that if you think about artists, right, the way they work, you have an image. You will try to modify an image multiple times, and then you'll realize, oh, this is the right thing. And you will then want that particular image to make it to the final cut. So now, if you provide a studio in the cloud, which Netflix aims to provide, an artist will work on an image multiple times. And if each version of the image is stored on the cloud, your cloud costs will explode. So what we do is we have these distributed infrastructure around the world where we can allow artists to store those temporary data. And then I specifically work on something called as Netflix Drive, which is like Google Drive, but for Netflix content. And so it is my responsibility to provide APIs to the artists so that once they're done with the iterations, they can publish the data to cloud. So in some ways, the temporary data lives in on-premise systems, and only the final cut makes it to the cloud. So it's a hybrid in that sense, but it is not at this point multi-cloud. We are totally invested in Amazon, AWS, and we have been with AWS for a while. So.
Okay, and when it works, it works. So no need to change running system,
Yes.
right?
Yes, exactly.
Yeah, perfect. That's also what we hear a lot. Like, just don't do something for the sake of just doing it. Do it if you really have a need for that, or if it solves an actual problem.
Yes. And the other thing is, although we do run on AWS, our services are designed in a way that they can run anywhere. So the same software stack that runs on AWS, we attempt to run it on-premise. So there is nothing that stops us from being multi-cloud today. We write our services in a generic way. We have abstractions that different cloud providers can plug in their implementations. But AWS gives us the scale, the requirements that meet our goals, and the pricing. So we have a relationship with AWS, which we use in Netflix.
And when you said like your culture obviously is based on a lot of trust and responsibility, ownership, freedom was a word that you have used a lot. So when it comes to that, how is it like about travel? When you say, okay, you're hiring more engineers, I assume that they basically also can work remote, right?
So today we are the product organization that I am a part of does support engineers to join remotely within the US at this point in time. There are our offices in Europe and in other parts of the world, and they may have different requirements. But for example, my team is open to hire remote within the US. So if anyone is looking for opportunities, and this was not always the case, the pandemic has now made us think, and this is a great way how like data informs our decisions and how we can change our thought process based on the changing environment around us. So that's how we do support remote work at this point.
Okay, but also interesting and good to hear that also Netflix, like it's actually good that it was not always like that at Netflix, because it also shows that you as an organization also kind of grow and change and adapt and so on and so on. It's just cool, really cool to hear. Then we have one question from Bernd, very interesting. Like that sounds very good and interesting, but can you say what are the downsides and challenges you have? A lot of freedom is good, but surely comes also with challenges, right? I would maybe add, like when we talk about trust, obviously if you, for some reason through the hiring process, you get in one guy who is maybe not that trustful anymore, and kind of isn't good for the system. So how would you actually identify that, and what would be your reaction? Maybe you can say something about these challenges and so on.
One thing that I missed, and this is a great place to put it in, is we also believe in constant feedback. So feedback is not something that you get at the end of the year or every 6 months. We believe in daily, or not even daily, like constant feedback. Like if I have a presentation, I'll constantly get messages from my teammates that, hey, this was great, or we could have done this better. And we believe in that technique to, identify people that are culturally fit with us. And Netflix believes, and you can read our culture document, that if someone is not good, we cut the cord at that point. We do not try to like harm the health of the entire team or the organization by keeping someone who's not culturally fit with us. And sometimes people are culturally different. They probably want to work at a place where they can be 80% or 70% of their capacity and capability. But Netflix wants all the folks to be at 100% of their capability and capacity. And we pay top of market for that reason. So that's our philosophy. We try to keep it very simple, and we try to put it out in the open so that people, when they come in, they exactly know what they're getting into. And there are downsides always to like taking one approach and sticking to it. In our case, too much freedom may sometimes mean that we actually have a lot of people working on a lot of siloed projects as well. So we are focusing a lot on trying to have a way for them to show that, so that we don't have silos that can continue to work on in different projects that may eventually come together in a platform together. So the other challenge that we sometimes face is because we have a flat organization. So everyone is a senior software engineer. We don't have levels in Netflix, like software engineer, staff, principal. So that may mean that growth is an interesting topic. Like, how do you imagine growth? And we are trying to work on interesting ways how we can provide growth opportunities to our engineers, and presenting at conferences as one way. Like talking, like building your skill set, doubling down on your existing skills are other ways in which you can envision growth. So that's how we are trying to deal with these challenges.
Okay, very, very interesting. Ready for more questions? We still have many questions coming, but we are good in time. No worries. Piotr is asking, he's working in an aircraft engine manufacturer. So something completely different, actually. And he's asking, how would you apply your DevOps culture, or your culture in general, maybe, to mission-critical industries where people's lives depend on, such as manufacturing aircraft engines? How would you convince your management that it pays off? And would you even recommend it?
So there are definitely caveats here. So for example, in my presentation, I said that uptime is not critical to Netflix, but there are organizations like healthcare and finance where uptime is more critical. So you will have to have guardrails and processes in place for that. I worked in Box, and Box is like Google Drive. It stores people's data. We have a lot of healthcare customers and health people that whose health depended on Box being up all the time. So we did have processes and guardrails. So I think that in every industry, that part is different. But I do feel that there are aspects of Netflix culture that can apply there. For example, the ability to keep it open to anyone to view and recommend, having constant feedback, a mechanism for people to reach out to anyone and provide feedback, and having informed captains, which is someone who may not always be like the manager or the director, but even amongst engineers, someone who can take the lead, someone who can get data and collect data before taking an informed decision. All of those principles can still be applied to any industry, even those that deal with mission critical operations. And I feel at the core of all the decisions are 2 points. One is data, and the second part is an informed gut. So you can go with your gut and you take a call and you stick with it. It is slightly difficult to do that when people's lives depend on it. So you need to be more critical of it. And therefore you need to take inputs from other people as well at that point in time. I think some variants of the culture can still be applied to that industry as well.
Okay, thanks. So Piotr, I hope this helps. If not, then, or if you have more questions, just submit it. Admir has a question. He's asking, how do you guys handle errors on production? Do you have any internal tools that help you there? So how do you do this whole monitoring topic and so on?
Yes. So we have algorithms and we have dashboards that each service owner provides, and they look at their services. We also invest a lot in service mesh, which means that if microservices are talking to each other, you can gain insight from how they are talking to each other. And if a microservice is down, we will know it with our alerts in place. The other thing is we try to fail safe. So when, let's say, some part of our backend infrastructure is down, we will have backups in place. We will have a mechanism to fail over, and we try to build it when we are building our systems. And there are times that Netflix goes down. There are times that I actually saw it yesterday when I was watching something on my phone, and then I went back to the television, something didn't work. So what I did was I went on Slack, which is our tool that we use. I just went out to the engineers who work on it, and I'm like, hey, this is not working. So can you fix this? And they worked on it, and then it was fine. So this is a great example of, users, but it was not life-threatening. It was just a bad user experience. So I think we kind of do not have the critical alerting that
people will I know some people where it would be critical, to be honest.
I mean, we want our users to love us, but at the same time, we want our users to not be like crazy for us. So I think, yes.
Yeah. Then Katrin, is Netflix also open for career changer coming from a different background? For example, data science to dev or so.
In general, we hire the best person for the job. So we do have openings in almost all career opportunities that you may seek. And so if you are a data scientist, and if you would like to become, let's say, a software developer, a core infrastructure engineer, I think Netflix may not be the best place, because we will try to hire the best person for the infrastructure position. And that's our philosophy of hiring. So, but we are looking for data scientists. So we would encourage you to start off as a data scientist, get the skills and opportunities within Netflix to explore and see where you can contribute in the infrastructure, and then take an informed choice to move to that group. So that's how we will be looking at it.
Okay, and I mean, I remember in your presentation, in your talk, you said the most important thing for you, or the first thing you look into, is actually the cultural fit, right?
Yes. For us, it is culture. And I mean, when I interviewed, the first thing, or all my rounds were almost focusing a lot on the culture part of it. So, which is very different as a software engineer. You generally go and you just code in all your interviews.
Yeah.
But here we had behavioral interviews, culture interviews, which was very nice, I think.
Do you have also a coding test or coding challenge or something?
Yeah. Yeah. So I had a take-home coding challenge, which involved writing a system with whatever I thought was correct. Again, any language of choice, whatever you can think. So I put tests, observability, metrics into my coding challenge, and that was something that I got feedback that was really great to put in. So we leave it to the engineers to choose the best tool and to develop their software the way they like.
That's really cool. I think Joseph, no, someone with the character H as nickname, is asking, is blockchain technology used in Netflix? Yes. If yes, how?
No, it's not used in Netflix. Yeah.
Simple answer. Interesting question. How do you decide which software or parts of the software to open source?
Our philosophy is that we use a lot of open source and we want to contribute back to the open source. There are some things that are tied very closely with how Netflix is built and Netflix services. So we try to abstract, like the thing that I work on, Netflix Drive. It was closely integrated with Netflix systems and services. So what I did was I tried to work with my team and abstract it out into a framework where different types of plugins can be placed that can have other systems interact with the Netflix Drive. And that is how we generally try to open source. We see opportunity. We try to abstract things out and make it generic enough that can be used by any industry. And so I would encourage all of you to look at our blog as well, Netflix Tech Blog. We have Metaflow, we have Netflix Drive, we have a lot of other open source. Spinnaker, which is our deployment methodology, that is also open sourced. So we believe in that.
Okay, then let's take the last 2 or 3 questions before we close the day.
Yeah, I may have to rush soon. So
okay,
if anyone has more questions,
let's take one question, last one, and then we are done. Let's take a technical question from Yassine. What is your approach with CI/CD on AWS? Do you enforce FinOps as well along your CI/CD?
So we use some generic CI/CD where we use Jenkins for our continuous integration, and we also use Spinnaker for our continuous deployment. And they work with AWS and can work with on-premise systems as well, because Jenkins and Spinnaker both support hybrid environments. And we do not rely a lot on the AWS provided primitives. We try to build generic solutions. So a great example is my software runs on Mac as well. But Mac VMs are not present, or at least when I started, were not present on AWS. We couldn't spin up Mac VMs there. So we had to then rely on Jenkins jobs and run on our Mac that was in our office. So to run tests. So that is a great way why we are informed choices of not going completely into a cloud provider's provided primitives helps. So that's a short answer for that.
Okay, perfect. Tejas, thank you so much for joining us today. I think I didn't promise too much to the audience when I said that this will be a great talk and a great ending of this mini conference. So thank you so much. I wish you a nice day. Good luck. And I hope also that you will join us again in the future for some of the upcoming events. That would be really great. And I would really love that. And the audience would love it as well.
Thank you so much. And thank you for moderating it so well. And thank you everyone for joining me. I hope I was able to help you understand a little bit more about how our culture works and provide ways in which you can think about it as well. It's been a pleasure, and I hope to join you guys soon.
Thanks.
Thank you.
See you. Bye.
Yeah. Bye.
Okay, so you saw it's not always just about software development. It's not only about the coding. It's also DevOps is not just about, how you do this with the cloud and how do you that and this. It's often really a cultural thing. And I think this talk was really, really interesting. And we saw it with the questions. Thanks for being so engaged in the chat and asking so many questions. I'm sorry if we couldn't take all of the questions, but I promise you we will get Tejas back on stage for one of the upcoming events again. So with that said, that was also our last session of this DevOps Best Practices Day. But as you know, we are not stopping. Next week, we have a .NET Day. Then we will have a mobile day. Then we will have again a DevOps day, I think, in November. And then don't forget, if you are interested in JavaScript, I mean, everyone is kind of using JavaScript in some way, at least the web developers. We have our JavaScript Congress coming up in November, from November 23rd to 25th. Make sure to save your spot, will be super interesting. We have the inventor of Angular, we have the co-founder of NPM, we have so many other cool speakers from all around the world, so make sure to join there. And also, if coincidentally or not, you are looking for a job or exploring the job market in Europe, visit WeAreDevelopers.com. We have many interesting jobs there, many of them with upfront salary information. Have a look, maybe there is something in for you as well. And with that said, I want to wish you good evening in Europe, good morning in the US, and good night actually in the more eastern countries. So that's it. Bye-bye from my side, and see you next week or at one of our next events again.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.